In this video, I'll give introduction to stack data structure and some of its applications where it is used and all. Then I'll be discussing abstract data type of stack ADT. Stack is a data structure which works on discipline last in first out. Actually, stack is a collection of elements, set of values, collection of elements. And those collection of elements, they are inserted and deleted by following this discipline. So if you are inserting the elements, then when you want to delete, which one can be deleted? Only the last one that was inserted, that can be deleted first. So this type of mechanism, we use it in our daily life at many places. See, whatever we do manually, we want to automate that one, that is computerize that one. So we write the procedures or the programs for those things. So we want our computers to do that. If we are using a stack in some application, then in our program also stack will be used there. Let us see few examples where stack is used in our daily life. So one example, if suppose there is a dead-end lane and in this lane cars are parked. Suppose there is a first car, this is a red color car, this is black color car, this is white color car. This is a dead-end lane and 3 cars are parked here. So it means they are brought inside this lane from this direction. Then if I want to take out these cars, from which direction they should go out? This side is closed, so they have to go out from the same direction. So this side of the lane they can go out. So which car was inserted last? White car. Which car will go out first? White car. So that's how last in will go out first. So last in first out, in short we call it as LIFO. So this is one example. Now let us take one more example. There is a can of balls. 3 balls are there, that is first red color, then green and then blue. Now from which direction I have inserted these balls in this can? This direction, this is the opening, this is closed, bottom is closed. Then if I have to take out balls, from this direction only they will come out. So which was the last ball inserted in this can? Blue ball. Then which will go out first? Blue ball will go out. If you look into the can, which is the first ball? Blue color ball. It's not red. Red I can't see. I can see blue on the top. So on the whatever is there on the top, that is first now. Even if you look into this lane, then which car you will find first? White color car. So that white car is first. So the recently inserted one becomes the first. So first for in what sense? The first one to come out. First one to come out. So this can of balls is also a stack. Even we can take the example of a stack of plates or a stack of papers, stack of grain bags. Grain bags are kept one above another. In the warehouses, stocking is done, so the products are kept one above another. So it is like a stack. So we cannot take out any product from the middle or from the bottom. We have to take out the products from the top. I'll give you one more example. Next example of stack. See, this is a railway track, that is tracks for a train track, rails track. Then this is one more track. This is an extended track. This is called as shunting yard. Now let me show you what is the use of this one. Suppose this is a train. This is an engine and behind that all cabins are there. This is engine. The point is the engine. So this is a train. It's coming in this direction. So it is facing in that direction. So it can go in that direction. If I take it on this track, then what entered first? Engine entered first. And the last cabin, suppose that the last cabin, that was inserted at last. Now when I take out from this one, so who is coming out first? That last cabin. Then when the engine will come out? At the last. So who will come out first? The last cabin that was inserted will come out first. Now watch this. I'll take it out in this direction. Now you can see that the direction of train has changed. It was going in this direction, so it has changed the direction. So by sending a train on this track and bringing it out from the track, it has changed the direction. So I can say that. So this we can call it as a stack. So if anything is inserted in the stack and we take out again, we can reverse that thing. So you can see that a train is reversed by using this type of track. So at junctions, at railway junctions, this type of tracks are available to change the direction of a train. So this is one more application of stack. Now one more, a general idea I'll give you. See, we have seen recursions. Recursions are the functions which call themselves. So their behavior is like loop, but they internally uses a stack. We have already studied about this one. So recursion uses stack. Can we convert a recursive function or recursive procedure as a iterative procedure? That is a procedure using loop. So from recursion, if we want to convert into iteration, yes, we can. So even a iteration can be converted into recursion. It is known that every recursion can be converted into iteration. But when you convert a recursion into iteration, sometimes we have to use a stack in iteration. Recursion uses stack, we know well. That is a system stack. We call it as a system stack. That is automatic. Programmer doesn't have to do anything. Compiler or the runtime system will take care of it. So we don't have to worry about it. But when we are converting into iteration, then we have to provide a stack. That will be called as a programmer's stack. So programmer should create a stack and implement the stack in the program. So we have to use a stack in our program. So sometimes when the recursions are converted into iteration, we have to use stack also. Not every recursion. Some recursions are directly converted into iteration. Some recursions we require a stack. So I will discuss this as a separate topic. I will take some examples and show you where the stack is required, where the stack is not required. So we will discuss this as a separate topic. But a general idea I gave you that if you have a known procedure in recursion and you want to convert into iteration, maybe you require a stack. And vice versa. If you have an iterative procedure and you are using a stack, means it can be done better using recursion. So that's all about introduction to stack. Now let us see ADT of stack. That is abstract data type of stack. So abstract data type will contain data representation and the operations on the stack. Let us look at ADT. Let us look at ADT of stack. ADT just gives the definition of a stack in terms of data representation and the operations. So let us see what is there in ADT. Data that is required is we need space for storing the elements. So as I said, a stack is a collection of elements. So we need space for storing those collection of elements. The next thing is we need a top pointer that is pointing on the topmost element in the stack, because the important one is the topmost element, which one was recently inserted. So top is a pointer pointing on the topmost element. Then these are the operations in the stack. Push means inserting a value, pop means deleting a value, peek means looking at a value. So let us see all the operations. I have taken an example here. Suppose this is a stack and this is the topmost value what I have inserted, and these are the values already present. So the first value that I have inserted was 10, then 16, then 20, then 25. So recently inserted one is 25, so top is pointing here. Now what does it mean by push? Inserting a new value. Suppose I want to insert 30. So insert it from the top. So as we know that always insertion and deletion is done from top inside the stack. That is from same end. So insert 30 here. So now which is the topmost element? This is the new topmost element. So let the top point here on position 4. So this is how we can push, inserting a value. Push means just inserting one value, right? Not all values. So if you want more than one value, call push more than one times. The next pop. Pop means deleting a value, taking out a value from the stack. So if we take out a value, topmost value will go, and next topmost value is this one again. So top will point on presently, whichever is topmost value, it will point on that one. Then peek means knowing a value at a particular index. So which is the first value inside the stack? 25. So first means not based on insertion, the based on deletion. So if this is a stack like a can, so if I look into the can, the topmost that I find is 25. So first value is 25, second value is 20, third value is 16, fourth value is 10. So I want to know which is the third value. So I should get the answer 16 from the top. So peek means looking at a value at a given position. It's not deleting, just knowing what is there. Suppose I want to know what is there at the third place. I got 16. Yes, I want to delete 16. So take out 3 values. So you get 25, then 20, then 16. Then you can take out 16. Like suppose the boxes are kept one above another. You want the third box from top. Then you have to take out topmost box, the next box. Then only you can take out that box. If you simply pull that box out, other boxes will fall down. So that's what we are imagining. We are having same type of data structure. So we are imagining that these elements are also arranged similarly. So to take out 16, I should delete or pop out 25, then 20, then 16. So pop is for deletion. Then next is stack top. This is not for deleting, just for knowing what is the topmost value in the stack. So right now the topmost value is 25. Just knowing the topmost value. Then is empty and is full, knowing whether the stack is empty or the stack is full. So right now stack is neither empty nor full. One more place is there. If I fill this place, then the size of the stack is 5, so it will be filled. So stack will be filled. Or if I delete all these values, then stack will be empty. So this is ADT. I have explained you. That is what is the meaning of all these. I have explained you. We have not seen the implementation. Now coming to implementation, how we can implement a stack? Let us recall once again. Stack is a collection of elements which follows discipline LIFO. So where do you store collection of elements? Array or linked list? Yes, these are the two physical data structures that we know. So we use these data structure for implementing a stack. We can implement a stack using array, or we can implement a stack using linked list. This is what we have to learn. So first we will see how to implement a stack using array. So when implementing a stack, we will implement all these operations. So that's all about introduction to stack and ADT. In the next video, we'll see implementation of stack using array. In this video, we'll look at implementation of stack using array, that is stack using array. We have already seen ADT in previous video. There we saw for a stack, definition of stack, we require data representation and then the operations on that data. So first of all, we need representation of data. So for implementing a stack, what are the things required when you are using an array? Look at this. I need a fixed size array. So I have taken an array of size 5 here. So this is the size of an array. So we need a fixed size array, and also we should know what is the size of that array. So I have one variable in which we can store size of an array. Then we need a top pointer to point on the topmost element. So yes, I have one more thing, that is top. So what should be the data type of this one? Integer, because it is pointing on the index. Whichever is the recently inserted element, there it will be pointing. So that is the index. Integer type, integer type. Then this array depends what type of values you are storing in this one. So we need total 3 things. We need an array of some size, and we need the size, and also we need a top pointer. 3 things we need for implementing a stack. Then one more thing. Inside the stack, we insert and delete the element from same end. Insertion is also done from top and deletion is also done from top. We say like this. We say like this. So from same end, we insert and delete. So here an array is having 2 ends. See, from this side also you can insert, this side also insert. What does it mean by this, inserting from either side? So I will write few elements and show you. Suppose I have few elements 10, 15 and 7. I have few elements. Then I want to insert one more element, that is 20. Where I should insert next element? Here or here? If I am inserting here, means I should shift all these elements. If I want, I can insert. But which is better? Inserting this side is better. Inserting this side. So we can say that this side the insertion and deletion is done. So if you remember, in one of the videos I have shown you insertion and deletion from that side is constant time. It takes constant time. If you say that no, every new element will come here only and we should shift the elements, then we are inserting from this side. So it will be order of n. So better we insert the element from this side. So let us quickly see what all we have learned. We require an array, we require size, and we require top pointer, and the elements will be inserted from this end, always from this end. And the top will be pointing upon topmost element. So suppose top is this one, so top will be pointing on this one, topmost element. Then how all the operations are performed, we will learn that one. Then one more thing. When we are saying stack, we usually imagine that it is vertical. It is vertical, like a can of balls that was vertical, or grain bags which are piled up one above another, that is also vertical, or a shunting yard that is on railroad, that was also vertical. And in recursion, at many places we have seen the stack, so that was also vertical. So usually we imagine a stack as vertical, so that array I am showing it as vertical. So we will be drawing vertical array whenever we say stack. Actually it's a normal array only, right? But to clearly see how it is working, this orientation is better. So we will be using this orientation. Actually it's an array, simple array. Then based on the things required for a stack, we require three things, right? We require three things, first, second and third. So for this, we will combine them together and we define a structure, like how we have been doing in the previous topics. So related things grouped under one name, we can define a structure. Let us define a structure for the stack. I will define a structure for stack. Let us call it as a stack. Then what are the members we require? First, I will take size, integer size. Then also I will take top pointer also, top pointer. So this is top. Then I need an array. So shall I declare a some size array directly, or shall we decide at runtime and create the array? We will decide at runtime and create the array. We will find out what is the maximum expected size of the stack and we create an array of that size. So then better take it as a pointer. Don't take a fixed size array, so that we can dynamically create a stack. So what are the type of elements that I will be storing? Mostly for learning purpose we use integer type only. So I'll use integer type array. So for that I will declare a pointer. So this is integer type pointer. So I'll be using this structure wherever I am using stack. So we'll follow this structure. Structure is having three members. It's a size and its top pointer and the pointer to an array. That array will be created dynamically. Next, let us see how to create this and initialize this stack. Inside main function, I will create the object of this, that is stack. So I will take a variable simply. So struct stack st. So st is a stack. Now once this stack is created, there are three variables in this one. So we'll get an object that is st having three things inside, that is size and top pointer and s is a pointer. Three members are there. Now I should know what is the size, because this array is not yet created. Array for storing element is not yet created. I have to create it. So I should know the size. So let us take the size as input from the keyboard. So I will write down, I will say printf enter the stack and I will scan this size value, that is st.size. So here I have written printf enter size of stack, then scanf read the value. Suppose the size of the stack is given as 5, then this size will be 5. This size is 5. So let us assume that this is 5. Now when we know the size, I should create an array of size 5 for storing the elements. I should create an array. Already I have a pointer. So let us create an array here and assign it to this pointer. So here is the code st.s. Okay, leave this. First let us read this. New int array. So create a new array from heap, new means heap. Of what size? st.size. So this is st.size 5. So new int of size 5. So an array is created and its address should be stored where? Here. So what is this? st.s. So st.s assign new int st.size. So an array is created and it is assigned here. Then one more thing I have to do. We know that top points on topmost element. Where is the topmost element? There is no topmost element. Then where top should point? It should point outside the stack. It means there are no elements. If the element comes, then it will come there. So where the element, first element may come at index 0, then where top should be before that. So let us take one more index here. This is not there in an array, just we are labeling it as index -1. So top should be at -1. So I should initialize this top as -1. So we say that top is pointing here at -1. So initially top should point at -1. So I should write on that code. So st.top assign -1, assign with -1. So these are the statements that will make our stack ready with this complete structure. Size is there, top pointer is there, and an array of required size is also created. So we are using entire thing as a structure. This is a structure. So next we will be looking at how we perform the operations on the stack where the array is like this. So we'll not be looking at this diagram every time. So the simple diagram we will see, that I will show you. So this is the structure that we'll be looking at every time whenever we say stack. So there is an array of some size I have taken, and this is size is 5, and top initially it is at -1. As we go on inserting the element, it will be moving and pointing on the topmost element. Now let us look at two important things here. When do you say this stack is empty? So right now it is empty. So what is the condition? See, top is equals to -1, then stack is empty. So yes, condition for empty is if top is equals to -1, then the stack is empty. Then when I say that stack is full, if all the elements are there and the top is pointing on this location, beyond this there is no space. So what is this location? Size -1. Stack full condition is when top is equals to size -1 at this location. So I will write on full condition. So top is equals to size -1 is a stack full condition. So we know the conditions also. So we'll be using these conditions wherever required. Now next let us look at all the operations one by one. I will explain how the operation is performed, and I will also show you the program code, that is the function for doing that. Let us look at operations on the stack. So the first operation is push. This operation is used for inserting an element in the stack. So let us see how to insert an element in a stack using array. Initially top pointer is pointing at -1, means there are no elements in the stack. So let us push a value. I want to push an element 10. So increment top pointer, move top. So how to increment? As it is an integer type, so say top plus plus, it will move here. Then at s of top, write down a value. Then I want to insert one more value, 15. So increment top pointer, top plus plus, top will move here and insert the value at s of top, that is s of 1. Top is 1 now. So s of 1, insert a value. I'll insert few more values. So right now top is here, which is at index 3. I want to insert one more value, that is 20. So yes, increment the top pointer and insert the value 20. Now this is important. I want to insert one more value, 25. Can I insert? Is there any free space available? No, there is no free space. I cannot insert because top is equals to 4. 4 is what? Size -1. So it means stack is full. So before insertion, actually I must check whether the stack is full or not. If it is full, I cannot insert it. If it is not full, I can increment top pointer and insert an element in an array. So that's all. This is the procedure. Check if it is full. If it is not full, then insert an element. Let us write a function for doing this. I will write a function push. This should take parameters. Two things. Now let us write a function for performing push operation. Push is the function name. What are the parameters it needs? It needs a stack in which we want to insert an element and what the element we want to insert. So two parameters are required. First one is stack type, that is this type of structure. Let us take it as st and also a value. Now one important thing. This push function should insert an element in this stack only, the one that is passed. So if you want to modify the same stack, then it should be called by address, that is called by reference. I should write a pointer here. Then what this function is going to return? Nothing. Let us call it void. So this is the prototype of a function. Now inside the function, first thing what I have to do, I have to check for this condition whether the stack is full. Means if the stack is full, I cannot insert any element. So let us check the condition. So top is equals to size -1. This is the condition for stack full. But I have used st. Yes, These two are inside this structure variable, that is st, and here it is a pointer, so I have to use arrows. So this st is a variable of this type, this is structure. So there are two members here, size and top, those members I am accessing, and this is for the array. This all we have already studied. So they are inside the structure, so I have to access them by using structure name. So first condition is top is equals to size minus 1. If so, then the stack is full. If I try to insert anything, then it is overflown. So I'll give a message that stack overflow. So if it is full, then say stack overflow. Otherwise, we can insert the value. So what is the method for insertion? We have already seen that top was incremented and the value was stored. Suppose this is not there, I am storing top. Then how to insert? First, increment top. So where is the top here? St is having top. See, this is top, right? So that's member. This is the member. So say st is top plus plus. So top is incremented. This will move the top to the next location. Then here I have to insert an element, that is s of top. So where is s and top? Both of them are this in structure. So I have to say st is s, then st is top. And here the value x is stored, the value that we want to push. See, actually this is s of top, but both are inside structure, so I am writing st is s and st is top. So this is the style of code we will be writing in the remaining functions also. So remember that these things are inside the structure which we have already discussed. So this is the method for pushing a value. Now let us look at next operation, that is pop, deleting a value. Let us see the procedure for deletion. If I want to pop out a value, right now top is pointing here and this is the topmost value. So take out the value and decrement the top pointer. The elements are till the place where top is pointing. So these are the values present in the stack. Then I want to delete one more value. So take out the value and decrement the top pointer. I'll delete few more. Delete this value, top is decremented. Then I want to delete this also. Top is decremented. Take out the value and the top is decremented. So top became what? Minus 1. Now top is minus 1. Can I delete any more values? No. There are no values. How do you say there are no values? Stack is empty. How we say stack is empty? Top is equals to minus 1. Yes. Top is equals to minus 1. Stack is empty. So before deletion we should confirm are there any elements present in the stack or not. If there are no elements, we cannot delete any element. If we still try to delete, then we say stack underflow. So let me write down a function for deleting a value from the stack. Function name is pop. If I want to modify the same stack, then I should pass it as reference or address. So it's of that type structure, stack star st. So I'm taking a pointer. So this pointer will be pointing on this stack. Example is the stack. So using the pointer, I'll be accessing all these members, that is size and the top and s. Now what this function should do, delete and return the value. So return type should be the type of values present in the stack. So we have integer type values in the stack because this array is integer type. So return type is integer. First thing what I should do, I should check whether I can delete any value or not. So it means I should check whether the stack is empty. If it is empty, I cannot delete. So first condition I will check if stack is empty. So what is the condition? Top is equals to minus 1. So I cannot say top directly. I have to say st is top. If st is top is equals to minus 1, then I should give a message that stack underflow. So stack underflow. If top is equals to minus 1, then stack underflow. Else, what I have to do for deleting? Else, take out the value from this place, s of top, take out the value. So for that, I will declare one variable x and also initialize it with minus 1. Why minus 1? I will show you. Now I will take out this value 15 and store it in x. So say x assign s of top, but both of these members can be accessed using pointer. So I have to say st is s, then st is top. So this is st is s and st is top. The value is taken in x. So if there is x, then suppose this is x, the value 15 is copied here. Then decrement top pointer, top minus minus. So we assume that this value is deleted. So I should decrement the top pointer. So st is top minus minus. Top pointer is decremented. Now finally, the value that is taken out from the stack, I should return it. So return this value that is present inside x. Here I write return x. So value is returned. Now one more thing, If the stack is empty, then there is nothing to delete. Then what this function will return? It is returning x. So if nothing is deleted in x, else part is not executed, means it will return -1. So if this function is returning -1 means stack is empty. There is nothing to delete. Otherwise, the deleted value. So like here, just now we had 15, so we got 15. If nothing is there, then it will be -1 only. That's all about push and pop. Now one important thing we have to discuss. What was the time taken for pushing an element? Just incrementing the top pointer and writing a value. So the time was constant. What is the time taken in deleting an element, popping an element? Just take out a value and decrement top pointer. If else, these simple statements are there. So it is constant. Time is constant. So earlier I have written push, that was also similar. So that time is also constant. So the time taken by push and pop operations is constant. Remember this. Now next operation is peek operation. Now next is peek operation or peep operation, finding an element at a given position. So inside the stack, what is the element at first position? As I already told you that this element is set to be first element. So position 1, then position 2, position 3. So if I give position 2, then I should get 8, right? If I say position 4, then I should get element 10. So actually if you see the indices in an array, this is index 0, 1, 2, 3. So the indices are moving up from here. But position means we have to start from top. So we need some formula to map this thing. So let us take some examples and study how we can build up a formula for this one. If I say position as 1, then what should be the index? 3. It should be 3. If I say position 2, then what should be the index? 2. If I say position 3, then index should be 1. If I say position 4, then index should be 0. How I can obtain this? So I think this top pointer can help me to find out the indices. So for position 1, I want index 3. So how it is possible? See, top is a 3. From that position, if I subtract 1, so actually I want the index 3 here, right? So okay, add 1 again. Let us see. Let us try this. Will it work for others also or not? See, top is a 3 and 2. 2 means position I want as 2. So 3 minus 2 plus 1. How much this is? This is 2. So okay, I got it. Then position I want a 3. So top is 3. 3 minus 3 plus 1. This is 1. And fourth position is what? 3 minus 4 plus 1. So this is 0. So yes, it is working. So with the help of top pointer, I can get the index in an array. So this should be taken as 3 minus 1 plus 1. That is answer is 3. 3 minus 2 plus 1. And 3 minus 3 plus 1. 3 minus 4 plus 1. So this index can be obtained by top minus position plus 1. So this is how I have obtained the formula from observation. By observing these positions and the top pointer, I have obtained the formula. So using this formula, we can convert the position into an index in an array. Let us use this formula and write a peek function. Function is peek. Then it needs a position. Which position element? And also it needs a stack. So I will send this stack as a parameter to this one. Function is peek. It needs a parameter as a stack. So I'll pass a parameter as a stack of this type. So stack st. See, I should write struct stack st, but in short I am writing just stack st. Then this should be called by reference or called by value. See, call by value is enough because here we are just reading the contents of the stack. We don't want to modify it. Second parameter, we want the position. So position. Then it should return a value found there. Okay. Then let us write the code here. Whatever the position is given, I should get the index using this formula and return the value from there. One more thing I should take care, whether the position is given valid or not. Right now there are 4 elements. So if I say I want to look at 6th element or 10th element, it's not there. So first of all, I should check if that position is valid or not. So if top minus position plus 1, this formula should not give any value less than 0. So if it is less than 0, then I should give a message that position is invalid position. Otherwise, I can return a value at a position, so and so position. So I will take the value in some variable and return it. So for that I will declare a variable x and also initialize it at -1. Then else I will take the value. So x assign from where I want the value. S of this formula. So this is inside st. So I should use this structure name st.s and st.top. So let me write it. X assign st.s of st.top minus position plus 1. So I have used the formula. So here also I should write on same thing, that is st dot. I have directly written this one. So st dot. Now finally return the value that you have found. So that is present in x. So return x. If the value is not found, an invalid index, then it will be returning -1. So if this function is returning -1 means value is not found. That's all with the peek. Now analysis. What is the time taken by this one? So the time taken is constant. The statements are very simple. Just if and else and some formula is there. So the time for this function is constant. Now quickly let us look at two more functions that are isEmpty and isFull. Let us look at remaining functions of a stack. First one is stack top. Just we want to know what is the topmost value in the stack. For example, here the topmost value is 20. So wherever top is pointing, we want the value from there. So here is a function stack top. It takes stack as a parameter, this whole thing as a parameter. This whole thing means the array, size and top. That's the structure which we have already seen in the beginning. So that whole thing it takes and check if top is equals to -1. If it is -1, then stack is empty. There are no elements. So this function returns -1. Otherwise, there are some elements. So wherever top is pointing, so it should return this value, So what is this value? S of top value. But this is inside structure st, so it should be st.s of st.top. So st.s of st.top, it should return this value. So that is stack top. And there are simple statements, so the time is constant. The next function is isEmpty. This is isEmpty. It takes stack by value, not by reference, because we are not going to modify this. So this is taken as a variable st. Then st.top, if it is -1, we know the condition, stack empty condition. This is stack empty condition. If it is -1, then stack is empty. Yes, it is empty. So return true. So we know well that in C language, true and false, true means 1 and false means 0. So true, it is returning 1. Otherwise, return false, that is 0. Then stack full. It will check whether the stack is full or not. If it is full, it will return true. Otherwise, it will return false. So it's taking this stack by value. And here it is checking whether top is equals to size -1. And both are inside the structure. So st.top is equals to st.size -1. This top is equals to size -1. If yes, then return true. So true means non-zero value in C language. So it is returning 1. Else stack is not full. So return false. That is 0. So 0 is false and any non-zero value is true. So we prefer taking 1 as true. So we have taken 1 for true and 0 for false. The time taken by all these functions is constant. So all the operations we saw on the stack takes constant time. That's all about stack using array. In this video, we'll look at implementation of stack using array. Let us start a project and call it as stack array, and the language is C language. Create a project, and this is the main function. I'll clear off all these comments. Now, first of all, let us define a structure for a stack. As we have already seen that for representing a stack, we need the size of the stack and a top pointer to point on topmost element in the stack and an array for storing elements. Let us call array name as S. I'll take capital S. This array I'll be creating it dynamically when I am creating a stack. Then when we create a stack, we have to initialize its size and the top pointer and also create an array. So for that, I will have one function called create. So this create function should take structure stack and call by reference st. Now here I will take the input from the keyboard, that what is the size of the stack, and I will create and initialize the stack. Enter size, then scanf percentile d. I should read the size, so already I have a pointer to a stack, so in that I will directly read it in size. Now once we know the size, we should create an array, but before creating array I will also initialize a top pointer to -1. Then this pointer s I should initialize with an array. So here I should create an array dynamically in heap. So it's an array of type integers, malloc, and the size of the array should be same as the size mentioned for the stack, and this should be size of integer. That's all. A stack is created. Size is set and its top pointer is initialized to -1 and an array is created. As I am using malloc function, here in the top I should include header file, that is stdlib.h. Now I will write on a function for displaying a stack. So first let us write a function for display which will take a structure stack st. This should be called by value because it's not going to modify a stack, just it's going to display. And for displaying we need a for loop, so for that I'll take I, and we should display it from the top. So I assign top I greater than or equal to 0 and I minus minus. I should print all the values, so percentile d, then some space, then the values are in a array s inside an object st. So this will print the entire stack. Then after printing it, I should give a new line so I get some formatted output. That's it. This is a display function. Now we'll write on few push and pop functions in the stack. Now we'll write on the actual operations on the stack, that is push and pop function. First I will write on push function, push void push. It should take a structure stack and it should take it by address and the value that I want to insert. Here, as we have already seen the procedure, so first of all I should check whether there is some space in the stack or not. If st's top is equal to st's size -1, then stack is full. We cannot insert anything. So printf stack overflow I will say, and new line. That's all. This is the message I can give. Else we can insert an element. So first of all we should increment the top pointer, and then in an array s I should store the value at top location, whatever the value is given, x. So that's all. This is a simple push operation. Then I will write on pop function. Pop function should return a deleted value, so return type is integer. It should take a stack by reference, that is by address, so again star st, and whatever the value is deleted we will take it in some variable, so initialize it to -1. Then before deletion we should confirm whether there are any elements in the stack or not, that is we check whether it is empty. So condition for empty is if top is equals to -1, then the stack is empty. If so, then we will give a message that stack underflow, a new line. Else we can delete an element. So for deleting an element, take a value from an array from location, that is top. And also we should decrement top pointer. So simultaneously in the same statement I will also write minus minus, so this will decrement the top pointer. And after deleting, after else part, I should say return x. So this pop function will delete the value if it is available, otherwise it will return -1 if the stack is empty. The other operations I will write them afterwards. So first of all let us use this push, pop and display functions and let us see how the stack is working. So first of all I will create a object of stack st. The stack name is st. Then I will call create function by passing address of stack st. Then I will push few values. Push in the stack st, the value I want to push first is 10. Then push value 20. I'll push few more values. Now let us display the contents of stack. So for this also I should send stack st. Let us run this. I have pushed 10, 20 and 30, so I should get the display from the topmost value will be 30, so I should get the values 30, 20 and 10. Here is asking for the size, so I will give the size as 5 and the values are 30, 20 and 10. Yes, it's working. The topmost value is 30. Recently inserted value is 30. Let us push more than 5 values and see what happens. st, I'll push 40 also, then push 50 also. Okay, then one more, push st 60 also. So I'm pushing 6 values in the stack. Let us run it now. So first of all, I have written the code such that it's asking for the size. So I'll give the size as 5. So only 5 values are inserted. You can see 10, 20, 30, 40 and 50. Topmost value is 50. And when I was trying to insert 60, it has given a message that stack overflow. So I got a message that is stack overflow because stack is full. We cannot insert more than 5 values. So beyond this, if I try to insert any more values, I get a message that stack is full, that is stack overflows. So I cannot insert this. Now let us try pop function. Pop function is going to return us the result. So I will directly print its result %d. I will take new line. Then call pop function and send address of the stack. So whatever the value is deleted, it will return and that value will be printed. So the recently inserted value is 50, so I should get 50. Then after that, when I display, I should have the values 40, 30, 20 and 10. Enter the size. So I'm taking the size as 5. Yes, you can see that 50 is deleted and the remaining values in the stack are 40, 30, 20 and 10. Now let us look at stack underflow message. So I will remove these 3 values. I will delete more than one time. So printf delete once more pop st. See, there are only 2 values in the stack. If I delete one more time, then I should get a message that is stack underflow. I should not be able to delete and it should return -1 because if the stack is empty, it is returning -1. Here you can see x value is initialized as -1, so it is returning x. Now stack is having only 2 values that I am pushing and I am printing, but I am deleting 3 values, that is 3 times pop. So let us run. I should get a message that stack underflow. Size, I am mentioning size as 5 only. See the values popped out or deleted values are 20 and 10. Then after that, when I am trying to delete stack underflow message, I got stack underflow. Then the value that is returned is -1. Now, as both the values are deleted, there is nothing in the stack, so there is nothing to display. So display function is not printing anything because stack is empty. That's all we have tried push and pop functions. Now let us write remaining functions of a stack, that is peak, is empty, is full and stack top. And in that way, we'll be completing all the functions of a stack. So first I will write down peak function that will look into a stack at a particular index. If the element is available, then it will return the element. So this, it will take it as index. I will call it as index. So it's taking a stack and the index. So whatever the value we are getting, we will take it in a variable. So initially I'll put it as -1 and I should check whether the index given is valid or not. So if st stop, that is stop, minus index +1, if it is less than 0, then it is invalid index. So let us print a message that invalid index. Otherwise, we can return the value. So first of all, let us take the value in the stack. So st.sArray, I should take the value from st stop minus index +1. Then I should return the value, return x. I will try this function, I will use it. But before that, let me write down other functions also. I should have a function called isEmpty. So it should take a stack, then it should check whether top is equals to -1. So if st's top is equals to -1, then return true. That is, yes, it is empty. Otherwise, return false, 0. This is isEmpty function. Then one more function I have to write down, that is isFull. So I will write function isFull, which will take structure stack st. Then here the condition is if top is equals to size -1. So I will simply say return top st's top is equals to st's size -1. If this condition is true, it will return 1, otherwise it will return 0. So if it is full, it will return 1, otherwise it will return 0. It's perfect. Then I should also have a function for stack top. So I'll give the name as stack top, struct stack st. This is again called by value. So it should return topmost element from the stack. So but before returning, it should check whether there are some elements in the stack or not. If the stack is not empty, it can do that. If not is empty, so it can call the function that is empty. If it is not empty, then it will return st's top value. Otherwise, return -1 if there is no top element. So if it is not empty, then it can return it, otherwise return -1. So that's all. We have all the functions ready for stack. See, one more thing, while explaining on whiteboard, I have not taken care of a strict syntax. Just for the explanation, I was writing pseudocode. Now here you can see the implementation exactly. So let us use this peak function. So for that, I will push few more values, then I will perform peak operation st.
comma 30, I will push the values what all I have pushed earlier. So same st40. Yes. Now instead of pop, I will call peek function. So here I will say peek. So I'm just modifying the code. I'm not writing a call once again. Now the index what I want is 1. That is the first element. So I should get 40. So let us run this. It's asking for the size. I have to give the size. Size is 5. Yes, topmost element is 40. That is index was 1. Now I will modify this one here. I have given index as 1, so let us give index as 2, so I should get the element 30. See, the element is not deleted from the stack. Stack is still having 40, 30, 20 and 10. Stack size, I'll give size as 5. Now the element from the top is 2. Second element is 30. So yes, this is the second element from the top, and the element are as it is, it's not deleted. That's all. This is full and is empty and stack top, you can try them. I have written all the functions. So if at all anywhere we require a stack in a C language program, then we will utilize this stack. If at all we require a different data type, then we will change the data type of this array, that is S, this pointer, and also wherever we are inserting an element, there we will modify it. Like this push is taking an element, so we will change the data type. So we have to change the data type of the element array as well as the other variables which are dealing with that array. So that's all. This is the implementation of stack using array. So the program is little lengthy and I have not elaborated main function. I have just tested the functions here. If you want, you can make a menu driven program for a stack with providing all the options like push, pop, peek and is empty, is full, all the options that you can try. Like one of the beginning programs, I have shown you a menu driven program. That same thing you can implement here.
In this video, I'll talk about implementation of stack using linked list, that is stack using linked list. Linked list we have already studied as a topic. So linked list is a collection of nodes which will have list of elements, a collection of elements. So stack is also a collection of elements, but insertion and deletion is done by using LIFO discipline. Let us learn how a stack can be implemented using linked list. So already I have a linked list here on board. This is the node structure of a linked list and this is the structure defined in C language. So everything is ready. Now there are no elements here. So first of all, let us discuss how we should insert and delete the elements. So in a stack, elements are inserted and deleted from same end. Now if you look at this linked list, there are two ends, that is left hand side this end and the right hand side this end. If I select this side for inserting and deleting the elements, then how much time it takes for inserting and deleting on this side? It's constant. If I select this side, then from the first node I have to traverse through this linked list, then only I can insert it. So the time taken here is order of n. So insertion and deletion from this end is n and this end is 1. So now you decide which side you should select for insertion and deletion. Definitely this side. Once we have learned about creating a linked list, so that time every time we were adding a node at the end, but here we will add a new node always on this end, left hand side. Now let me fill up few elements. Let us assume that this is the first element I have inserted in the stack. So stack is still here. Then I want to insert 15. So this node is inserted and the value is 15. Then one more value I want to insert 8. So this node is created and inserted, 8 is inserted. Then I want to insert one more value. So this is value 3. So this is the latest value that is inserted in the stack. So where is the pointer? So we have pointer first here on the first node, but now I will call that pointer as top. Let us say top is a pointer pointing upon first node. So now always new element is inserted from top, that is on the left hand side. Now what are the elements in the stack? 3, 8, 15, 10. Which is the topmost element? Wherever top is pointing, the first element or the first node is containing the first element in the stack, and that is the recently inserted element in the stack. Now let us see, if I want to push any element, how I can push it. I should create a new node here with the help of some temporary pointer and insert the value, then make this point here on this top, and top should be brought on this new node. This is the method of inserting. So we are familiar with this one. This is inserting at index 0. How much time it takes? Constant. So we'll be selecting this side for push. Then if I want to pop a value, that is delete a value, Then if I want to pop or delete a value, so take a pointer upon first node. This is the first node. So move top pointer to the next node, then delete this node. So this node is deleted. So that's how deleting an element at index 1, that is deleting first node. We have already seen this. This is same as that one. How much time it has taken? Constant. So I have shown you how to push the element and how to pop the element, that is delete the element inside the stack using linked list. So it is same as inserting at index 0 and deleting from index 1, that is deleting first node. Next, let us look at some condition. Two important conditions are there. When do you say stack is empty? When there are no nodes, no elements, then we say stack is empty. So that time top will be null. So if a top is null, then stack is empty. So I'll write down the condition here. Empty condition. If top is equals to null, then it is empty. Then we also need one more condition, that is stack full. In an array, the size of an array was fixed, but here it is unlimited. If you want to set the size, that is your choice. But this is unlimited size. You can insert as many elements as you want. Then when do you say stack is full? If you are unable to create any new node, means heap is full, then stack is full. So if you are creating a new node and it is not getting created, then stack is full. So for that, I will write down the full condition here. Create a new node. If it is not created, then t will be null. If t is null, then stack is full. So that's all about stack using linked list. How to represent, that is using the same node structure, and from which side we should insert and delete, from this side. What is the stack empty condition? What is stack full condition? Now let us see the operations on the stack using linked list. Let us see push operation, that is inserting a element in the stack. There's a push function which takes parameter what is the value to be pushed. So top pointer, assume that it is global. Top pointer is a pointer of type node, just like first or head pointer of linked list. Now what we should do in push? Check for full condition. For that, create a new node. Create a new node. If node is not created, then it is full. If node is not created, means t is equals to null. When we are creating a node, t is null, means node is not created. Then print stack is full. Printf stack overflow. Else, if suppose the node is created. So I will also draw it. Here the node is created. Then fill up this node, make this point on this one and move top. So inside else, I will write on, copy the data here, x value here. T's data is x. T's data is x. So suppose the value is 20. I have inserted 20. Then make this point on this node. T's next is top. T's next is top. So this will point on this one. Then as this is a new node, top should be brought here. So top should be brought on T. Top is assigned with T. Now remove T, we don't need it. So that's all, these are the steps. Simple steps are there, inserting a new node before head node or before first node. That same procedure we have followed, and the time taken is constant because the steps are simple steps. And this function works even if you are inserting first node. Let us check it. If you are inserting very first node, that time top pointer will be null. And if you create a node, suppose the node is created, this is not null, so come into the else part. T's data assign some value, so okay, assign some value. T's next is top, so what is top? Null, so this becomes null. Then top assign T, so top will come upon T. Then remove this T. Now you can see that this is the only node and the top is pointing on that node. So even if it is first node, it works. The same function works. Now let us look at pop function, deleting function. So we know well that deletion is done from this side, so we will delete this node. Let us look at pop function, how to delete. Actually we have to delete first node, but before deletion what we should check, whether there are some nodes or not. Means if it is empty, we cannot delete any node. So check for this condition. So I'll write here, if top is equals to null, then stack is empty or underflow. Printf stack is empty. Otherwise, we can delete a node. So let us see what is the procedure for deleting first node. Else. Now for deletion, I should have a pointer, some pointer here. Let us call that pointer as p. So I need a pointer. So I will declare a pointer also here, node star p. Then p assign top. So p should be pointing on first node. So p or t, anything you can take. I am usually taking p here. Now move top to next node. Top should move on to the next node. Top assign tops next. Then take out this data. P's data, take out in variable x, x assign P's data. So this data is taken in variable x. Then delete the node. So this node will be freed. Free P. Even I can write delete P or free P. Then the last statement also I have to write after else, that is return x. I should return the deleted value. There is no space, just I am writing here return x. So whatever the value is deleted, that value will be returned. If it is unable to delete, because if the stack is empty, then it will return -1. So if this function is returning -1 means stack is empty. Next, let us look at peep or peek operation. Now let us look at peek operation, which takes position and gives you the value at that given position. For example, if position is 1, then what is the value at 1 position in the stack? 20. What is the value at position 2 in the stack? 3. Or position 3, the value is 8. Position 4, value is 15. So this function takes the position and gives the value at that particular position. Suppose I want 10th position value. So first, second, third, fourth, fifth. Beyond that there is nothing. So invalid position. We cannot give a value. So we return -1. So let us see how this should work. Peek function takes a position. Suppose, for example, I have given position as 4, that is fourth position. Fourth position means 1, 2, 3, 4. This is the fourth node. I want to know the element present here, that is 15. So for that, I should traverse through this linked list starting from top node or the very first node. So for that, I take a pointer p and make it point on top here. Then to reach fourth node, how many times p should move? 1, 2, 3. So it should move for 3 times. 1, 2, then 3. So after moving 3 times, it can reach on fourth node. So by using for loop, I will move P until it reaches that given position or it has become null. So I will write on the code here. See, I is starting from 0 and I is less than position -1, I plus plus. And before that also I am checking P is not null. If it is null, then we don't have to go beyond that one. So also check whether it is becoming null or not. Then move it for position -1 time. So for moving, P assign P is next. So this will be moving P to next node every time. So this for loop will take P upon that particular position if the position is valid. If it is invalid, P will become null. So I should check whether it is valid or invalid. So after the loop, check if P is not equal to null, means it is valid. Then return the element at that position, 15. Return P's data. This is not deleting, just we are sending the value, copy of a value. If it is null, then return -1. Else return -1. It means that position was invalid, so we don't have data there. That's all with this peek function. So we don't need this x, I have already declared initially, but we don't need it. So we have directly returned the value. Instead of taking an x and sending it, I have directly taken the value. So this is a peek operation, that is finding an element at a given position. Now remaining small operations are there, that is stack top is full and is empty. I will directly write down their code and just quickly explain you. So here I have a stack top function, stack top. If top means top is not equal to null, then return the data present at top. So it returns the data. Otherwise, it will come to this statement and return -1. Means Data is not there and the stack is empty. Then is empty function. If top is null, then it is empty. Otherwise, it's not empty. If top means top is not null. Not null means return 0. Else means it is null, so return 1. 0 means false, 1 means true. So if top is not null, then return false, otherwise return true. Then is full function. For checking whether it is full or not, create a node and check. So create a node and check if that T is not null. If it is not null, assign 1 to R. Otherwise, assign 0 to R. 1 means true, 0 means false. Means if it is not null, assign true. Otherwise, assign false. And after that, delete the node and return R. So whatever the value was stored in R, that will be returned, true or false. So that's all. These are the functions for stack. So all the operations we have seen, and every operation take constant time. All are simple functions. So whenever we need a stack, we may be using either stack using array or we may be using stack using linked list. Whichever one you want, you can use that one.
In this video, we will write a C language program for stack using linked list. Stack linked list, and the language is C language. Project is ready. Now for implementing a stack using linked list, first of all I should have a linked list. So even I can use the existing program for linked list. Already we have written the program for linked list. That same functions I can use them here, but I will write them again here. Struct node. First of all, I should have a structure for node. We should have some data and also a pointer to next node. So it's structure node and the pointer name is next. So this is a definition of node of a linked list. Then here a top pointer I need. So top pointer I will take it as a global variable and I will initialize it as null. So even I can declare it inside main function and pass it as parameter to the functions. Otherwise, taking it as global, if I have only one stack in my program, then I can go for this method. Though this is not recommended, we should have a pointer inside the main function and we should pass it as parameter to the other functions. Now the functions that I should have are push and pop. So I will write on only three functions, that is push, pop and peek functions. Void push function. This push function should take a value to be inserted and we should push it into the stack. So let us implement this function. So this function should first of all create a new node, struct node, using a temporary pointer t, and a t assign I should create it using malloc function. I should create it using malloc function struct node. This is a typecasting, and call the malloc function, and how much size I need, I should mention a structure name. So this will create a node. Then t's data should then before pushing I should check whether the stack is full. Here the stack is not having any size, so if node is not created, it means the stack is full, or actually heap is full. So I can give a message. So I can give a message that stack is full or stack is full. And also I'll give a new line. Otherwise I can insert a node. So for inserting a node, already I have created a node, then I should set the data for this node as x and set the next pointer as top, and the top should be pointing onto this node t. Yeah, one thing, I should do all these things inside else part, that is if stack is not full, then I should do all these things. This should be enclosed inside else. Yes, I have done it. Now the next function is pop function, which will delete the topmost element from the stack and it will return that element. So for deletion, first of all, it should check whether the stack is empty. If top is equals to null, then the stack is empty. We cannot delete any element. So it can print a message that stack is empty. A new line. Else we can delete an element. So for deleting an element, I need a temporary pointer. So I will take a temporary pointer, struct node, star t as a temporary pointer, then t should be pointing on the top node, that is topmost node. Then top should move to the next node, top assign tops next. Then take out the value that whatever we want to delete, that is then take out the value from the topmost node. So t's data, t is pointing on that node. Then free that node t, delete that node. And for this I need one more variable, integer x, and which is initialized to -1. This will take the deleted element and it will return it. So at the end I should say return x, value x is returned. That's all, two functions I have written. Now the last function is display function. So void display function. This will display all the elements. So for that I have to scan through a linked list. So for that I have taken a temporary pointer p for scanning through a linked list. Then p assign top. Then while p is not equal to null, that is p is not equal to null, I should scan through a linked list and display each and every element. So printf %d, give some space, and I should display the elements using pointer p's data. And after displaying all the elements, I should give a new line. So for formatted output, I'll give a new line. That's all these functions are ready. Now I can use main function. Yeah, and one more thing, while it is scanning through a linked list, then p should move to a next node. Inside the main function, I will call few functions for pushing and popping the elements and also displaying. So I don't have to create a stack because already I have taken a top pointer as a global variable. If I am not declaring top here as a global variable, then all these functions must take parameter as a stack. So I made it as global, so directly I can call push and pop function. So let us call push function and push few values. 10. There is no upper limit, so there is no chance of stack getting filled because we have taken the limit as heap size, so that may be taking n number of elements. So I am pushing 3 elements, then I will call display function. It should display all the elements. Then inside printf, I will call pop function and display its data. Pop function. So that's all with the main function. Let us check few things. Here a top pointer I have declared, so this is accessible for all the function. This is a pointer, so I should make it as star. Actually I missed this star. Then let us run the program. Yes, these are the elements when I display them, and the topmost element is 30, so I deleted that one. So pop has given me the element. So that's all. And for utilizing this stack, wherever if I need in my application, then I need this node structure and the top pointer that is declared in the top or as a global. Then I need push and pop functions. If I need any other function, I can write down that function for the stack. I can use these functions inside an application wherever stack is used. That's it. In this video, we'll write a C++ class for stack using linked list. I'll call the project name as stack llcpp, that is for linked list, and the project language is C++. Yes, create the project. Project is ready. I'll clear off all the comments. Now here inside the program, first of all, I should write a class for stack. I'm calling it as a stack, same name. Then what are the private members? So inside the private members, first of all, I should have a top pointer as a node type. So what is node? So I will go back and write a class for node. A node will contain two members. One is the data that I want to store, and other one is a node type pointer. So next is the pointer. Then these members, I want them to be accessed publicly so that I can use them inside this stack class. Now inside the stack class, I have a top pointer. Then that's all I need, nothing more. So then in the member functions, the very first function I should have is a constructor. And this should be a non-parameterized constructor only because there is no size for this stack using linked list. So by default, top pointer is null. That's all. So this is a default argument, that is no argument constructor. I don't have to take any arguments. Then the other function that should have is push, which will insert an element, and a pop function that will delete an element and return the element. So it should be of type integer because the stack is integer type. Then one more function is display function. That's all. These are the functions I am going to implement them. I'll implement them outside. So the first function is push function, and first is I should write a class name. So I should call it as push, and parameter is integer type. For pushing, first of all, create a new node using temporary pointer. New node is created, and then check whether if the node is created, if t is equal to null, means node is not created, then I can give a message that stack is full and I will not insert any node. Else I can insert a node, so else block I will write down. So a node is created, so I should set the data for a node as x, and t's next should be pointing on top pointer, and the top should come upon t. That's all. A node is inserted, that is, a value is inserted in the stack, pushed in the stack. Now the next function is pop function. So first of all, class name and scope resolution, function name is pop, and it should not ask anything. First thing, it should check that if top is equals to null, then stack is empty. So we can give a message that stack is empty. We cannot delete any element. So I have given /n here. Else we can delete an element. So for deleting an element, I should have one temporary variable outside, that is x, which will take a deleted value and initialize to -1. Then x assign top's data, Then I need a temporary pointer to help this node to be deleted. So I'll take that temporary pointer upon top. Then move top to next node, top assign top's next node. Then after that, delete t, node is deleted. Then return the element that is deleted. That's all. There's a pop function. The next I will write down display function. So its a class name is stack, scope resolution, display function, which will display all the elements. So for displaying all the elements, I need a temporary pointer to traverse through a linked list. So using a loop, I can traverse it while p is not null. Then every time I should display a value from p's data and also give some space in between the elements. Then the p should be moving to a next node. At the end, I will also give endl for new line. That's all. The class is ready. I have written 3 functions, that is push, pop, and display. The other functions you can implement. Then here inside the main function, I'll create an object of class stack. Here inside the main function, I'll create an object of stack stk. So object is created. Then I should call stk.push. I will insert an element, that is 10. Then stk.push, I will insert one more element. stk.push, I'll insert one more, 30. That's it. Then I will say stk.display. It should display all the elements. Let us run this. Remember, for using scene and cout, you have to write using namespaces. Yes, all 3 elements are pushed into the stack. I can see all these elements. Display is displaying them. Now let us pop out one of the element and see what happens. Cout, I will directly call the function pop, and I'm displaying the result given by that one. So 30 should be popped out. Yes, here 30 is popped out. 30 is deleted from the stack. So you can check these functions, push and pop and display, all the functions are working. That's all with the class for stack using linked list.
In this video, we'll look at the application of stack. One of the application of stack is parenthesis matching. Let me explain what the problem is. Expression is given or a formula is given which is parenthesized. This round brackets are called as parentheses, so it is parenthesized. We have to find out whether the parentheses are balanced or not. Means for every opening parenthesis, there must be a closing parenthesis. This is what we want to check. That's all. Problem is very simple. For every opening bracket, there must be a closing bracket. So how to check this one? So for checking this, a stack can be used. So let us see how we can take the help of a stack and find out whether the parentheses are balanced or not. I'll take a stack. Yeah, here a stack is ready. So I'm not showing top pointer, it's not required. We know how it works. Now let us see the procedure. In the procedure, we will scan through this expression by taking one symbol at a time, one character at a time. Let us start. This is the first symbol. It's a opening bracket. Push it into the stack. If it is opening bracket, push it into the stack. Next symbol. This is also opening bracket. Push it into the stack. Next symbol is A. So it's neither opening bracket nor closing bracket. Some other letter. Just ignore it and move ahead. So it means if you are getting opening or closing bracket, then only you have to respond. Otherwise, just move ahead. Let us move to the next symbol. This is plus. So move ahead. B, move ahead. Now I got a closing bracket. So what we should do now if we are getting closing bracket? Whenever we get a closing bracket, pop out a bracket from the stack. That's it. Just pop out one symbol from the stack. One symbol I have popped out. But don't push that closing bracket in the stack. It means we found a match. That's all. Move ahead. Next, this is asterisk. It's neither opening or closing bracket, so move to the next symbol. This is opening bracket, so push it into the stack. Then move to next symbol. This is plus C, just ignore. Minus, ignore. D, ignore. Closing bracket. So once we are on the closing bracket, pop out a symbol from the stack and move ahead. Next symbol, closing bracket, pop out a symbol from the stack, move ahead. So we have reached the end of a expression and check the stack. Stack is empty. So it means the parentheses are matching. Now let us take an example where it may go wrong. So let us take an example where the parentheses are not balanced. Then what happens? Here in an expression, I have added one more extra opening bracket. So if you count 1, 2, 3, 4 opening brackets are there and 1, 2, 3, only 3 closing brackets are there. Let us see what happens in this case. So one red color opening bracket I have added, that is extra. So they are not balanced. So let us see whether this procedure will help us or not. Let us quickly go through that procedure. It's opening bracket, push. Next one is opening bracket, push it. Opening bracket, push it. A, ignore, plus, ignore. B, ignore, closing bracket. Pop out a symbol. Move to next. Ignore, opening bracket, push it. Then C, minus, D, closing bracket, pop out. Closing bracket, pop out. End of expression. But stack is not empty. There is something left over for which there is no match found. So it is not matching. Parentheses are not balanced. Now let us take one more example where it may go wrong or it is not balanced. In this example, I have taken an extra closing bracket. Let us see what happens in this one. Let me scan this quickly. Opening bracket, push it into the stack. Opening, push it into the stack. A, ignore, plus, ignore. B, ignore, closing bracket, pop out. Asterisk, ignore, opening bracket, push it. C, ignore, minus, ignore. D, ignore, closing bracket, pop out. Second, closing bracket, pop out. Next, one more closing bracket, but the stack is empty. So there is no match found for that closing bracket. There is no opening bracket available. So that's all. From the observation, we can say that if you are scanning through an expression by pushing opening brackets and popping out whenever you get closing bracket, in this procedure, if at the end the stack is empty, then they are perfectly matching. If at the end any opening bracket is remaining, it's not matching. And if we have one closing bracket but the stack is empty, there is no opening bracket, then also it is not matching. So there are two situations when it is not matching. You have finished the procedure but there is something left over. Second situation, you are trying to pop out but the stack is empty. So let us write a procedure and see this one. But before that, I'll show you one example. Look at this example. This is not a proper parenthesization. This is not a proper parenthesization. Parenthesization is done upon an operator for including the operands that belong to that operator. So here operand and operator are there that are enclosed in the bracket. So where is the second operand? So it's outside the bracket. So this is not proper parenthesization. But let us check whether it is balanced parenthesis or not. Let us try it. Opening bracket, push it into the stack. A, ignore, plus ignore, closing bracket, pop out a symbol from the stack. Then opening bracket, push it into the stack. Star, ignore C, minus D, ignore all of them, closing bracket, pop out a symbol from the stack. End of the expression, there is nothing in the stack, so it means parentheses are matching. So conclusion is, this procedure doesn't check whether the parentheses are properly given or not. It will check whether the number of parentheses are matching or not. For every opening, there is a closing bracket or not. So just balancing of parentheses, it will check. Let me write down the program and show you. Let us write a function for parenthesis matching. Here is a expression. I have taken it as an array of characters, that is a string. So array of characters terminated by null character. So it's a string. So expression is represented as a string. Next, I have a function called isBalance, so it will check whether it is balanced or not. If it is not balanced, it will return false. If it is balanced, it will return true. Then it takes the parameter that is a pointer to a character. So it can access this array, that is array of characters it can access. So pointer to an array works just like a name of an array, right? So I am taking a same name expression. Now let us write down the procedures. Now first of all, we need a stack. So I will take a stack of type array. So for that we had a structure, if you remember. So that stack I will take. So let me create a stack. Struct stack st. So stack is ready. So this variable is of type that structure we have seen earlier, but one change we have to do is the array, data type of an array, we have used integer, but here we are going to push characters, that is symbol, opening brackets. So we should change the data type of a structure as character. So I will write the structure and show you. If you remember, the structure for stack was having size, top and a pointer to an integer, but now we have a pointer to a character. So this is structure we'll be using. You have to modify the structure. Next we will see how to initialize a stack, how to initialize this one. So this is stack. I have to initialize it. I have to set the size of the stack and also set the top pointer. So I will do that. Just watch it here. So I will set the size, st.size. So what should be the size of the stack? It depends on number of opening brackets because we are just pushing opening brackets. So how do I know how many opening brackets are there? So I assume that at most I have opening brackets equal to the size of the expression. So let us take a little bigger size, a stack that is equal to the size of the expression. So I should know the length of that string, and that should be the size. So I will take the size of a stack, that is st, as string length of this expression. String length is a function, you can call that one and it will give you the length of a string. That is the size. Now next thing I have to do is top pointer as -1. Top pointer is -1. Then I have to create an array of given size. So dynamically I will create an array, st.s assign new. So here I have created an array of type characters because as I said, we have to push characters in the stack. So the stack type I am taking it as character stack. So an array of characters is created of given size, whatever the size is, then its pointer is pointing to s. So let us see the structure also inside the memory. If you remember, this is structure. This is the structure. So the first thing, size we have set. So the size of this one is a 13. So 13 is set here. Then top pointer is -1, top is -1. Then an array of size 13 is created. So this is how a structure looks like in the memory. But we imagine that the stack is like this, right? So for our understanding, this is sufficient. We don't need to see this complete structure every time. So these are the statements that we require for initializing that stack. So we need a stack and also we have to initialize it. I will remove these lines because I need space for writing the remaining piece of code. Let us write the procedure. In the procedure, we have to scan through this expression going on each symbol at a time, starting from 0 until we reach null. So for that, we can use a for loop. Accessing a string, we do usually using for loop. So I will write on the for loop. So for this for loop will scan through this expression for I assigned 0, that starts from 0, and it will be going on incrementing I plus plus until this expression of I is not equal to /0. So when it is reaching /0, that is null character, string terminator, it will stop. So when it becomes equal, it will stop. So this will scan through this expression. Now inside this, while scanning, what we have to do? If it is opening bracket, push it into the stack. Let me write on that. Here, if expression of I is equal to opening bracket, symbol is opening bracket, then push it into the stack. So stack name is st. I am sending it by reference, that is I am sending address of a stack and also a symbol, that same symbol, whatever the symbol is. Then next, if it is not opening, else it must be closing. Next I will write for closing. Else if that expression of I, means that particular symbol wherever I is pointing, if it is closing, then what we have to do? We have to pop out. But before popping out, check whether there is something in the stack or not. If the stack is empty, means there is no matching found. If you remember, if I have opening bracket and closing, watch this. This is there inside, this is there inside. Then for this one I popped out this. Then for second one also popped out. Now I am at closing, but the stack is empty. So I should check if the stack is empty. If the stack is empty, then there is no matching found. So first of all, I'll check here. If a stack is empty, matching is not there, so return false. So here I write on the condition. Yeah, I'll read out. If is empty, we have already written this function. st, call by value, no need of reference. If is empty, this function will return true if the stack is empty, otherwise it will return false. So if it is returning true, then if true, then return false. False for what? Because there is no matching bracket in the stack, because stack has become empty. Still we need one more opening bracket, right? That is missing, that is the meaning. So that condition I have taken care. If matching is there, stack is not empty, then just pop out and continue. So this is pop out. Pop out function is taking again the address of a stack. So it will simply pop out a symbol, that's all. And we will continue, we will not do anything. So this else part closes here. So if it is opening bracket, push it. If it is closing bracket, pop out. And before popping, check if the stack is empty. Then we say we cannot continue, return false, means they are not matching. That's all. These are the things I have to do. That's all. If it is opening or closing, I have to react. Otherwise, let it simply go on moving forward. So I will be moving forward. And once it has reached /0, it will stop. So I will close this for loop. Now once it has came out of this for loop, means it has finished the complete expression. Now once the expression is completed, there should not be anything remaining in the stack, right? So if you remember, I'll show it again. See, suppose I have two opening brackets, just one closing bracket. So let us do it. Push, push, and for this one popped out, and I have reached the end of the expression, but still stack is having one opening bracket. Means there is no matching symbol found. So stack should be empty when you have finished scanning. Stack should be empty. So I have to check whether the stack is empty. If it is not empty, then again false, it's not matching. Otherwise true. So I will write on the code here. I will read the statement. Return is empty of st. If the stack is empty, means if it is empty, means true, means there is matching. Matching, true. Otherwise return false, means it's not matching. If something is remaining left over in the stack, then it's not matching. So that's all. This is the procedure for parenthesis matching. I will write on a program and show you, and inside the program I need everything related to the stack, because this procedure uses a stack. So I will write this in the program. In this video, we will develop a function for checking parenthesis matching. Already I have discussed that function on whiteboard. So let us write a function for checking parenthesis matching.
So I'm using the program which I already have written using C language for stack using linked list. So already I have push, pop and display functions. And this node structure is having data. This data should not be of type integer. It should be of type character because we have characters in expression. Then in the pop function, push function should also take a character. It should not be a integer. In C language, we don't have templates, so we should modify the data type everywhere. Now this is of type character and the pop function should return a character type value. That's all. I think I have made all the changes. Now let us write a function for checking whether the parenthesis is balanced or not. So for that, inside the main function, first of all, I should take an array, that is expression exp, and to this I will make it as a pointer so that I'll take it as a string, and I will give a expression a plus b multiplied by c minus d. Now parentheses are closed. I have given a balanced one. Now this I will be passing to a function, so as a string, that is array of characters. So I should have a function which will take a array of characters, that is as a string, and its return type is integer to return whether true or false, is it balanced or not. So I will call the function name as is balanced, and it should take a character type pointer to an expression. So this is a string. Now I have to use a for loop for scanning through this expression. So I will take I, then using for loop I will scan through it for I is assigned 0 and expression of I is not equal to /0. So until it reaches /0 it should continue, then I++. Then inside the for loop I should check whether a symbol at expression of I is equals to opening bracket. If it is opening bracket, then I should push it into the stack. Push expression of I. Else I should check if it is a closing bracket. Expression of I, if it is a closing bracket, then I should check if the stack is empty. How to check if the stack is empty? I did not write any function for stack empty, so I will say if top is equals to null, it means the stack is empty, so there is nothing in the stack, so I should return false. False means 0. Otherwise I should pop out an element from the stack and I don't need that element, and I should continue. That's all. At the end of the loop I should check if the stack is empty. So if top is equals to null, means there is nothing in the stack, then I should return true. Yes, it is balanced parenthesize. Otherwise, if there is something remaining in the stack, I should return false. That's all. End of the function. Here from the main function I will call and print its output directly. Percentile D call is balanced by passing an expression. It should return true. Yes, it has given 1, that is true. I'll try to remove one bracket and let us run this. False, it has written false. I'll give 2 extra brackets. Let us run this, it should return false. Yes, false. That's all. You can implement this function by yourself. Here is a student exercise similar to parenthesis matching. The same problem is a little bit extended. So let me explain you what the problem is. See, this expression is parenthesized, but these are not just parentheses. Brackets are there. So different types of brackets are there. Flower brackets, or they are called as braces. Round brackets, they are also called as parentheses, and square brackets. So different type of brackets are there. So the problem is we have to check whether the brackets given are in balance. So let us check this one. So this problem can also be solved using stack. So let me take a stack and trace this and show you how it should work. Here is a stack. Let us scan through the expression. First one is flower bracket, braces included. Opening bracket
included, opening square bracket included, A skip plus skip, B skip, closing bracket. So for this closing bracket, when I pop out something from the stack, it must be a match for that square bracket only. So yes, it's an opening bracket. Perfect. Square opening bracket. So it's perfect. Then don't do anything, just continue. Asterisk, ignore it. Opening square bracket, okay, push it into the stack. C, ignore. Minus, ignore. D, ignore. Closing square bracket, so pop out. So what we get from the stack? It's a opening close bracket. So yes, it is matching. Match is found. So continue. Then closing bracket. So for this closing bracket, so pop out from the stack. We got this opening bracket. So yes, it is match for this one. Perfect. Then just ignore and continue. Next, ignore the symbol, ignore the symbol. Then this is the closing bracket. Pop out symbol from the stack. So it's a flower bracket. So it's an opening bracket for this one. Yes, it's matching. Everything is matching perfectly. At the end, stack is empty. So it means the brackets are balanced. Let us see if they are not balanced, then what happens. I'll change the symbols. I have changed the expression. Let us trace this one and see how it works and what problem arises. Opening bracket, push it. Opening bracket, push it. Opening bracket, square bracket, push it. A, ignore, plus ignore, B, ignore. Closing bracket. So for this closing bracket, pop out. So what is the opening bracket we are getting? Square bracket, it's not matching. It should be a square closing bracket, but actually it is round bracket. And what we got from the stack is square bracket. So it's not matching. So that symbol should also match. This is not just having one type of bracket, that is round brackets or parentheses. It's having different type of brackets. So you also have to check whether the brackets are matching or not. So what you have to do in the procedure? Let me explain a little bit what are the things that you have to focus on. Now I'll explain you how it is different from the previous procedure. So what's the extra thing that you have to take care for writing a program for this one? Let us see. This is a string and this is a character type stack, and we have to scan through this expression by taking one symbol at a time. First symbol. Now what are the things I have to check? Is it a flower bracket? Is it a round bracket? Is it a square bracket? Earlier we were just checking it was a opening bracket, just one parenthesis, opening bracket, round bracket. But three things you have to check. If it is any of these three, then push it into the stack. Yes, flower bracket, push it. Round bracket, okay, push it. Square bracket, okay, push it. Then similarly, I should also check whether it is a closing bracket of flower bracket or square bracket or round bracket. So instead of checking just one symbol, I have to check three symbols. If it is any of those three, push it. If it is any of these three, that is closing bracket, round bracket or this flower bracket, then pop out, pop out. So extra conditions you have to write down. So I'll just give you the sample. If expression of I is equal to flower bracket or expression of I is equal to round bracket and that is square bracket, push it into the stack. ST and expression of I. So I have not written all three conditions. So I gave you the idea. This part or this one or next one. Flower bracket, round bracket or square bracket also you have to write down. If these are matching, push it. Other way, if it is closing bracket or square bracket, then I should pop out and take it in some variable. Then this you have to check whether it is exactly matching with the type of a bracket or not. So that code you have to write down. That is the extra work you have to do. So it's a student exercise, do it. Now one hint I can give you, because you have to check so many things, that for this flower bracket, closing bracket, it should be flower opening bracket. For a round closing bracket, it should be round opening bracket. So three things you have to check. I think you can make it little simple if you know this hint. I'm giving you a hint. So the hint is, I have the ASCII codes for those brackets. See, for round brackets, ASCII code is 40 and 41. So these codes are below 50. Then for square brackets, the codes are 91 and 93, and for flower brackets, it's 123 and 125. So if the codes are less than 40, the difference is of 1, 40 and 41. If they are greater than 90, then the difference is of 2, 91 and 93, 123 and 125. There is a difference of 2. So by using this, if you can reduce the code, the size of the code, for you don't have to write so many ifs and else. By using this, you can write some tricky code to reduce the number of conditional statements. Anyway, if you're writing many conditional statements also, no problem. Write a program for this one. The topic of this video is infix to postfix conversion. We will learn what is postfix and why we need postfix. Then what are precedences. Then we will learn how to convert a infix expression to postfix as well as prefix manually, that is using pen and paper. Then in later videos we will see how to convert it using a procedure. There are three notations of writing an expression. The first one is infix. This is commonly used. In mathematics we follow this notation. So basically we know only one notation, that is infix notation. What is it? First operand, then operator, then operand. If it is a binary operator, like plus is a binary operator which will add two operands. So operator will be in between two operands. This is the common method that we use, that is used in mathematics. But in computer sciences, apart from this, we have discovered or introduced two more methods, that is prefix and postfix. So let us see prefix. Prefix means operator, in short I have written here, then operand and then operand. So example, that plus operation, binary operation, comes before two operands. So first you will have operator, then that operation has to be performed on A and B. Then postfix, operand, operand, operator. So first two operands, then the binary operation plus. This means A added with B. This means add what? A and B. This means what? A and B. Do what with A and B? Add. So this is a single operation I have taken with the two operands. So directly I have written them in the infix, prefix and postfix form. If an expression is having more number of operations, then how it looks like in prefix and postfix, that we have to learn. But before that, we will see why do we need prefix or postfix. Basically, we have been using infix. Then why this prefix and postfix? Let us see this. Now, why we need postfix or prefix? Let us see this. See, if I have given this expression to you and asked you to find the answer for this one. So you have to evaluate this. So for evaluation, what you will do? Will you first add 8 and 3? No, you know Bodmer's rule in mathematics. The higher precedence is for brackets than the powers. I'm assuming that you know Bodmer's rule. So let me evaluate this one. See, first I have to solve this one. So I'll first go to bracket. So I have skipped plus and multiplication, then directly jumped here. Then I'll see, oh, power. So I will evaluate this one. So this is the first one and this is the second one. Then anything more? No. So now multiplication, divisions are leftovers. Now as per in mathematics, division is higher precedence. So I will perform this one, third one. Then this division, fourth one. Then I'll come here, fifth one. Then addition are remaining. So this is the sixth one. Then this is the seventh one. If you observe the order in which I have performed those operations, I will show you them. First this one, second here, third, then fourth, then fifth, then sixth, then seventh. So I am jumping here and there in the expression. I have to look into the expression and find out first which one I should perform, then next which one, then next which one. So for finding out which one should be performed next, I may have to scan this whole expression. Yes. So it means I have scanned this expression for multiple times. Otherwise, it's randomly moving here and there in the expression. So can we write a program which behaves like this? Which will jump directly here, then it will go power, then division, then multiplication. So we can't write a program. This is a random behavior, so we cannot do this. So if you write a program, then you have to make it search for highest precedence. First finish brackets, then finish powers, then finish divisions. So one by one, it has to scan the expression for each type of operators. So this is more time consuming. What we want is, We will not scan this expression multiple times. Just in one scan, we want the result. It's not possible. In fixed form, it is not possible. Then is there any other form by which it is possible? Yes, postfix form it is possible. So to give you the idea and to finish my discussion, I will write on the postfix form of this one. How I am getting it, don't bother about that. So here I have a postfix form and expression. Don't worry how I got it. We will learn. Now let me evaluate this. Based on the mathematics Bodmer's rule, I have converted. Let us see. I'm evaluating this one. 8, operand, ignore, go ahead. Operand, go ahead. 9, operand, go ahead. 6, operand, go ahead. Minus, perform minus first. So which operation is getting performed first? Minus. You see here also we have done the same thing. So minus is performed over what? Previous 2 operand. Assume that this is performed. Over. Finished. Then move ahead. 2 square. So this is square upon 2 only. So this is the second one. So you can see this was the second one we did. So this is completed. Now move ahead. Divide. Divide what? Previous 2 values. What are those values? This underline is 1 and this underline is 1. These two should be divided. So you can see that third one when we perform, this divided by this we did. So the operators are arranged in the order in which they are supposed to be evaluated there. They are arranged in this order. So that's why whenever we are coming across an operator, we are performing operation on previous 2 operands. So if it is arranged in postfix form, it can be evaluated in just one single scan. So finally, I can say that the purpose of writing an expression in postfix form is that we can scan the expression only once and perform all the operations. If it is an infix, it's not easy to evaluate it in one single scan. But how to write it in postfix, that's what we have to learn. So let us learn how to write it in postfix. Here I have a precedence table. I have not taken all type of operators. I have taken just few operators: addition, subtraction, multiplication, division, and also brackets. Addition subtraction is having lowest precedence, and both addition and subtraction have same precedence, equal precedence in programming. In mathematics, minus is having higher precedence than plus, but in programming they both have equal precedence. Remember this. Same way, multiplication and division also have same precedence, but they have higher precedence than addition and subtraction. Then bracket is highest of all, so I have given the number as 3. Now here I have 2 expressions as an example. Here we will learn how to convert them from infix to prefix as well as postfix. Now for conversion, the important thing. Remember this, whenever you write an expression, actually you should make it fully parenthesized. Fully parenthesized. You should not write an expression without parenthesis. Make it as a first rule. Is it fully parenthesized? There are no parentheses at all. No parentheses at all. So parentheses are not given. Actually, compiler needs fully parenthesized expression. Everything should be parenthesized. No operator should be left open. Then when they are not parenthesized, then compiler will parenthesize it, not physically, logically, it will parenthesize it. How? By using precedences. This is the very important concept. Precedences doesn't mean order of execution. Suppose in this one, multiplication is there, highest precedence. It doesn't mean first multiply. No. What operation will be performed, it's a different thing. But that is having higher precedence means first put that one inside the bracket. First you parenthesize that one, then you parenthesize additions and subtractions. That is the meaning of precedence. So precedences as well as associativities are meant for parenthesization. So let us do parenthesization and then convert infix to prefix and postfix. So first I will parenthesize this one, properly parenthesize this. See, A plus B into C. So let me parenthesize this. In this one, who is having higher precedence? Multiplication. So this is multiplying what? B with C or A plus B with C? B plus C obviously. So put that one first in the bracket. Put this one first in the bracket because this was having higher precedence, multiplication. Now next, What is the remaining operator? There is only one operator. So put that one in the bracket. So this is A plus B, just B? No, A plus B into C. So put that whole thing in the bracket. That's it. So this means that this A should be added with the result of this one. That's the meaning. So parenthesization gives you clear-cut meaning what operation should be performed on which set of operands. That's what. This precedences gives you the same idea. Let us convert first into prefix. So for prefix, first we write operator, then we write operands. So for this one, prefix. Inside this one, which bracket should be evaluated first? This bracket should be evaluated first, innermost one, right? So for that, convert it into prefix. So I will write everything as it is. A plus B into C should be written as what? Star first, then B, C. And I am putting in the square bracket to show that this is completed. Next step, which bracket? So round brackets only, right? This round bracket will perform next. This we have finished. Now next one, this whole thing will perform. Then that is having what? A plus this whole thing. So prefix means first write plus, then left hand side and right hand side. So first write plus, then A, then right hand side we have star BC. So okay, write on complete thing. Star BC. So this is the prefix form of that expression. Now let us write postfix for this one. In this, which bracket is evaluated first? This one. Convert that into postfix form. A plus, this is round bracket, BC star, converted into postfix. BC star. I will put it in the square bracket to show that this is converted. Now, which bracket is evaluated next? This bracket is evaluated, right, for this operation. So, write it in the postfix form. Left hand side A, right hand side BC star, then write plus, plus. This is the postfix form. So, quickly let me show you the procedure. First of all, you fully parenthesize it based on the precedences. Then, whichever one has to be evaluated first, you go on evaluating them in the order of their evaluation. So, but don't evaluate, convert it into prefix or convert it into postfix. Now, one more thing I would like to add. See, prefix is not much used. Postfix is used. So, infix, operator is in between. Postfix, operator is at the end. Now, only one thing is remaining, that operator is in front. Let us include that also. That is prefix. But we don't use it, we use postfix. I have one more example, so I will quickly solve that one and I will show you a few more examples and solve them quickly so that you get the idea how to convert them and you should be able to convert it by yourself. Let us convert this into prefix. I'll write on the expression once again, A plus B plus C star D. I will not write parenthesis, it will be too much congested. So directly I will show you. Who is having higher precedence? Multiplication is having highest precedence. So this has to be converted first. So this portion, that multiplication is between C and D. So I will write on A plus B plus this in prefix. So first star, then CD. I'll put it in square bracket to show that that is completed. Now next, who is having a higher precedence? Only two are remaining, plus plus, and both the plus are same only. Then which one I should take? I cannot take as per my wish. I cannot select anyone randomly because all are same. I should take them from left to right. Remember this. If the precedences are same, then take them from left to right. So first this plus. So let us convert this into postfix form. So plus, then AB, that is the prefix form of that one. I'll put this also in the square bracket to show that this is completed. Then star CD. So this is completed, this one is completed. Now what is remaining? This plus. So this plus has to be done upon what? This left hand side and this right hand side, on both. So prefix means first write plus, then left hand side is plus AB, right hand side is star CD. So this is the prefix form of expression. Now let me show you the postfix form. This one. A plus B plus C star D. So which one is having highest precedence? This one. So this is upon what? Left hand side is C, right hand side is D. So A plus B plus CD star postfix. As I have finished this, let me put it in the square bracket to show that that is completed. Now next, What are the operators remaining? Plus, plus, equal precedence. Which one should be done? Left hand side. This one. This plus is upon what? A and B. So convert into postfix. A, B plus. Put it in the bracket to show it is completed. Then plus as it is. This is remaining as it is. Then what is remaining? This plus. This plus is upon what? This is left hand side and this is right hand side. So write on left hand side A, B plus. Then right hand side C, D star. Then write plus. This is the postfix form. So this is the postfix form of the expression. So I have taken one more example and shown you how to convert into prefix and postfix. I'll take few more examples and show you. Next expression. This is already having brackets. Converted into prefix. First prefix. So I'll write on the expression once again. A plus B star C minus D. So which one has to be performed first? Bracket. But I have two brackets. So which bracket to take first? Left hand side. So convert this one first. So I am writing prefix. So plus AB. Put it in square bracket to show that this is completed. Then star as it is. Then inside brackets C minus D. Then what is the next one? Multiplication or bracket? Bracket is having higher precedence. So convert this into postfix form. So this left hand side is as it is, then star also same. Then this has to be converted to prefix. So this is minus CD and this is prefix. Now what is remaining? Everything that is completed is in square bracket. So whatever is outside is remaining. This star is remaining multiplication. This one. So this is upon this left hand side and this right hand side. So write the prefix of this one star first of all. Then left hand side plus AB. Then right hand side minus CD. So this is the prefix form of expression. Then let us write the postfix form of this expression. A plus B star C minus D. Now which one first? Two brackets are there. So left hand side bracket first. So this one in the postfix form AB plus completed star then C minus D as it is. Now next bracket, this is C minus D. This has to be done. So take this left hand side as it is. Then convert that one into postfix. So CD minus, put it into the square brackets. Now this multiplication is remaining upon left hand side and right hand side. So AB plus CD minus star. This is the postfix form. So I think these examples are sufficient for you to learn how to convert an expression from infix to postfix. So practice this one. So you can watch it again and again. If you are facing any problems, watch it again and again. And you should be able to convert it. Just by looking at an expression, you should be able to tell what is the postfix form of this one. That much practice you must have. If you understand the logic, then you can understand other things also. In this video, we'll learn about associativity and unary operators. So two things we will discuss. What does it mean by associativity and how to handle unary operators while converting infix to prefix or postfix. So let us see what is associativity. To discuss associativity, I have taken few operators here, some of the operators. These we have already used them in the previous example, addition, subtraction, multiplication, division, and this is a new one, power operation, and this is unary minus. This is unary minus. I'll show you what is it. So these are the new operators I have introduced. Now if you see the precedences, this is 1, then this is 2, so the higher than that is power and higher than this unary minus, then highest one is brackets. And associativity, if you see, few of them is having left to right and few of them is having right to left. So let us understand what these are. See, already I said that precedences and associativity are meant for parenthesization of an expression. If you don't parenthesize it in your program, then compiler will logically parenthesize them based on these precedences and associativity. Now what is associativity? Let us see. This is an expression. I have more than one operators having same precedence. Plus, plus, minus. All of them are having same precedence. Then which one we should select first? Check the associativity, left to right. So you must select them from left to right. If this expression is properly parenthesized, then it looks like this. First a plus b is put into the bracket, then second plus is included, so this whole thing is kept in the bracket. Then next minus is taken, so this whole thing is kept in the bracket. So parenthesization is done like this. So it means first is this plus, then second one is this one, and the third one is this one. So we have to take them from left to right. Now I'll give you one more example. See, this type of statements we can write down in the program, that A assigned with B, B assigned with C, and C assigned with 5. So how it works is, first 5 is assigned to C, then that 5 is also assigned to B and also assigned to A. So you can observe that it is working from right to left. So there are more than one operators which are having same precedence. All are assignment, they are having same precedence. No doubt it's not there in the table, but we can see that they are all same, so their precedence is equal. Then which one we should take first? So as I just now explained that, first 5 value is assigned to C, then that value is assigned to B, so it's working from right to left. Yes, its associativity is right to left. So if I am parenthesizing it, then based on the associativity I have to do, because precedence is same. So let us see how parenthesization is done. First C assigned 5 is put in the bracket, then this assignment is taken, so this B, this is kept in the bracket, then this assignment, so this is A, this whole thing is kept in the bracket. So parenthesization will happen from right to left. So from these two examples we can understand that there are two types of associativities, that are left to right, then right to left. Yeah, here this is left to right associative and this is right to left associative. So if precedences are equal, then we look at associative. Let me show you the postfix form of first one, then also I will show for second one. Let us convert this into postfix. If I convert this into postfix, first this part will get converted, so this becomes AB plus. Then this bracket, next bracket. So left hand side is already completed, so C, then plus goes after C, so C plus. Then this is completed, this whole bracket is completed from here to here. Then this minus is upon this whole complete left side and D. So left side is already there, then D, then minus. So this is the postfix form. Let me write the postfix form of this one. So first this has to be converted. So C5, then assignment. Then this bracket I have to take. So B assign this complete right hand side. So B as it is, right hand side as it is, then assignment goes after this. Then come to this bracket, outermost bracket. So because this portion is already completed. So A assign this whole thing. So this whole thing is already there. So A, then this complete thing in the bracket, then assignment. So this is the postfix form of this expression and this is the postfix form of this expression. So postfix is dependent on the parenthesization and the parentheses are dependent on precedence and associativity. Let us look at few more examples upon right to left associativity operators. I may be using some operators which are even not there in the table. So let us see the examples. Now in this example, A power B power C, this one, power operator. This is a famous one. Mostly for right associativity, most of the authors take this operator, power operator, to explain right associativity. This symbol is caps symbol. So instead of using caps, some authors use a dollar symbol also. So I am using caps here. So this is power. This is right to left associative. So it means there are more than one operators in the same expression. They are having same precedence. Then how they should be parenthesized? They should be parenthesized right to left. So if I parenthesize this one, then it looks like this. First this is in the bracket, then this one is in the bracket. Now I will convert that into postfix. So I will write the same form of expression and convert it into postfix. See, which one should be converted into postfix first? So already I have kept in the brackets, but let us, without brackets, let us follow it. How to follow this one? There are two power operators. So which one should be converted into postfix first? This one, this one. Okay, convert this one. So this becomes BC power. Put it in the square brackets. Then A power as it is. Now next, this power. So for this power, this is the left hand side, this is the right hand side. So take left hand side, take a right hand side, that is BC power, and then take the operator at the end. So this is power. So this is A, B, C, power, power. Now one more thing. If we look at this mathematically, what does it mean? A power B Then C is a power of what? C is a power of B. So this is how it looks like. If you say no, this is left to right associative, if you want to try that one, then left to right associative means first A power B. So first A power B. Then this entire thing is given with power C. So entire thing with C. It will look like this if the associativity is from right to left. No, power operator is having right to left associativity. This operator is not there in C language. This used to be there in previous languages, older languages. Now let us take some unary operators and convert them into prefix and postfix. Minus A. This is negation of A. This is unary minus. Unary minus. Precedence is highest, just less than bracket. Highest precedence. And associativity is right to left. So first right then left. It means if there are more than one, then we have to do it from right to left. So we will see that. First of all, let us write this in prefix. So if I write it in prefix, then how it looks like? This is minus A only. Then what is the postfix form of this one? This is A minus. Then if suppose I have minus minus A, then which minus should be put in the bracket first? Right to left, as I said. So this minus goes in the bracket first, then this one, obviously. So that is minus of A and it's minus. So first right hand side minus is taken, then left hand side minus is taken. So you can convert this into prefix and postfix. Now next operator I will take. This is dereferencing operator in C language. This is used for accessing the data wherever pointer is pointing. This is the regular form. So I can say this is the infix form. Then what is a prefix form? So prefix will also be same. It will be star P only. Because it's not a binary operation. This is a unary operation. We have only one operand. So either it has to come before operand or after operand. So this is before operand. Then postfix form of this one. So how it may look like? P star. Then if there are multiple operators, star star P means what? Which is done first? How they must be parenthesized? Right to left. So first star P, then again star of that whole result. Yes, we know it well. That is goes from right to left. We have done it like this, but now we are observing it. Now I'll take one more example of unary operator. N factorial. What is the prefix form of this one? Prefix form of this one is first factorial then n. What is the postfix form of expression? This is n factorial only. This is in the same normal form. So normal form is this is nothing but infix, I should say. So this postfix is same as infix. Here prefix was same as infix. Prefix was same as infix. But here postfix is same as infix. Now one more operator, log x. Log x. What is the prefix of this one? Operator name is log. So it will be log x only. Then what is the postfix form of this one? It will be x then log. Postfix. So operator comes afterwards. So I have to write it afterwards. Operator comes before in prefix, so it's already before only. So I should take it as it is. So there are few examples of unary operators I have shown you. Unary operators in languages usually will have highest precedence and they will have right to left associativity. Next I'll take one example and we will convert it into postfix. This is an expression. Now based on the precedence and associativity, if I directly convert it into postfix, who is having higher precedence? Unary operators. Who are unary operators here? Minus, log, factorial. They all have same precedence. We are assuming that they all have same precedence. But what is the associativity? Right to left, unary operator. I just wrote minus here, but include all of them here. So right to left associativity. If it is right to left, then which one I should convert into postfix first? This one, factorial. I will rewrite the expression minus a plus b star log. Postfix of n factorial is same only, n factorial. That one is converted. Now next, who are remaining? Minus and log, they have higher precedence. Right to left, so first convert that log. So minus a plus b star, convert this. Log of this one. So postfix is n factorial, log goes afterward. Now I will enclose this into complete. Then which one? This is the unary operator, higher precedence. Complete this first. So a minus, put it into the brackets. So A minus, put it into the bracket to show that this is completed, plus as it is, B as it is, star as it is, this is completed. So n factorial and log. Now who are remaining? Plus and multiplication. So who is having higher precedence? Multiplication. So this multiplication is upon what? Left hand side is B, right hand side this whole thing. So this I will write as it is, then plus. I have to convert this into postfix. So first left hand side B, right hand side n factorial log, and this should be inside bracket. The last one remaining is plus. So this plus is upon this left hand side and this right hand side. So first write left hand side without brackets, let us write it A minus, then right hand side B n factorial and a log, right hand side is completed, then write plus. So all are completed, so I will not write bracket. So this is the answer. So this is the postfix form of this expression. Let me show you what are the operators I have performed. First I have performed this, so I got this result. Then I have performed this one, so I got this result. Then I have performed this one, so I got this result. Then I perform multiplication, so I got this result. This was the multiplication. Then I perform addition, so this was the result. So first factorial, then log, then minus, then multiplication, then plus. So that's all about associativity and unary operators. How to handle them while converting into postfix form, I have explained you. Prefix is an exercise for you. You can try that one. In this video, we'll look at a procedure for converting a infix expression into postfix expression by using a stack. Already I have an infix expression given here. This expression is using very limited operators like addition, subtraction, multiplication, division. Their precedence table is given here. Addition, subtraction is having precedence 1 and multiplication, division is having precedence 2. If you want more operators, you can increase the table size and add their precedences, and that same procedure will work on them also. But to understand the procedure, we are taking a small example. Let us see how to convert this. So for that, I will take a stack and show you the procedure. Let us see the procedure. So for that, we require a stack. So I will take a stack. Our stack is ready and I have to generate a postfix expression. Now let us start the procedure. So in the procedure, I have to scan through an infix expression by taking one symbol at a time. While scanning, what we have to do, let us see. First symbol, it's an operand. Operand means send it to postfix. Write it in postfix. Next symbol, it's an operator. Operator plus, its precedence is 1. Is there anything in the stack? No, nothing is there. So push it. Push. I will write its precedence here just beside it. Next symbol is an operand. Send it to postfix. Next symbol, operator. What is its precedence? 2. Its precedence is 2. Look into the stack. Is there anything? Yes. What is there on the top? Plus. What is its precedence? 1. And what is the precedence of this one? 2. So this is greater. So push it. Move to next symbol. C. Operand. Send it to postfix. Next symbol. Operator. Minus. What is its precedence? Precedence is 1. Its precedence is 1. Is there anything in the stack? Yes. On the top, asterisk is there. What is its precedence? 2. So the precedence of this minus is smaller than this one. Pop out. Pop out this one. Means if this is greater, pop out and send it to postfix. Then check again. This is minus precedence 1. What is there in the stack top? Topmost value is plus and its precedence is equal. So precedence is equal. Then also pop out. So pop out this one and send it to postfix. So it means if it is an operator, we should push it into the stack. And before pushing, check what are the operators present in the stack. If the operators in the stack have lower precedence, then push that one. Otherwise, pop out. Let me finish. So this minus, push it into the stack. Precedence is 1. Then next is D. D is an operand. Send it to postfix. Then slash, its precedence is 2. This is 1. Push it into the stack. Next is E. Send it to postfix. Then end of expression. We have reached the end of the expression. So whatever is there in the stack, empty it and go on adding the contents to the end of postfix. So slash comes out, then minus comes out, minus. That's it. This is the procedure. So once again, I'll show you like a revision quickly. Operand, send it to postfix. Plus, there is nothing in the stack, so push it. B, operand. Star, this is 2, precedence is 2, and the precedence here is 1. So that is greater, so push it. C, send it to postfix. Minus, precedence is 1. The one inside the stack is having greater precedence, so you cannot push that one here. Pop out this one. Asterisk goes out. Precedence is 1. Precedence is 1. Even it cannot be equal. Pop out this one. Plus goes out. Nothing in the stack. So nothing in the stack means no problem. The precedence is 0. Let us assume it as precedence 0. So push that one into the stack. Minus. Then next D goes to postfix. Slash, its precedence is 2. So it comes here. Then E. Then end of expression. So pop out these two and add them. That's all. This is the procedure. I'll prepare a table and show you what all things are happening in this procedure so that it is easy for you to remember it. I have taken a table having all these symbols, that is the expression is here. So every symbol is taken separately, and this is what a stack contents are, and this is postfix expression. So how the procedure was working, let us look at. There is nothing in the stack initially. This is operand, it will go into postfix. Operator, push it into the stack. So postfix remains same. B, it's an operand, so this will go into postfix, and stack is containing just plus. Then star is pushed into the stack. So first star will be there, next plus will be there inside the stack from top if you see. And the postfix is same thing, AB. Then C, it's an operand, so this goes into the postfix, and the stack contains star and plus. Then minus, when it is minus, this star will pop out, so and it will be added to postfix. Then plus also is popped out, it will be added to postfix, and minus is pushed into the stack. D, it directly goes into postfix. A, B, C, star, plus, and D. Then stack is having minus. Then slash, so it will be pushed into the stack because it is having higher precedence than minus, and the postfix remains same. A, B, C, star, plus, D. Then E, this goes into postfix. A, B, C, star, plus, D, E, and the stack contents are same. Now end of expression. So here the expression ends. So everything from the stack is popped out and added to postfix. So the result is A, B, C, star, plus, D, E, slash, minus. So this is the postfix. So each step you can see it in a table. See, usually when you have any procedure that is iterative, that is repeating, and you want to see the contents of all the variables or the data structure, you can prepare a table and you can see the content. So we are looking at the contents of infix expression and the stack contents as well as contents of postfix. How they are changing, we are looking at them. So this is a tracing of the procedure we have done. Now let us look at the procedure once again with some minor changes. What is the change? Look at here. See, the precedence table was having addition, subtraction, multiplication, division. Now I have included variables also, operands also. I am assuming that operands have higher precedence, that is 3. Operands are also there. So it means I am going to push operands also into the stack. Yes, let us see how the procedure works. In the procedure, every symbol from infix expression will go into the stack. Every symbol. Previously, we were sending operands directly to postfix, but now everything goes into the stack and still it works. Let us see how. First is A. It's an operand. What's the precedence? 3. Is there anything inside the stack? No. Push that one in the stack. So I'll write its precedence also here along with it. The next is plus. What is the precedence? 1. What's the precedence in the stack? The stack top is having A, its precedence 3. This is higher. So you cannot push any symbol in the stack if already higher or equal precedence symbol is there in the stack. So if already something is higher or equal in the stack, you cannot push. So pop out this one. So the conditions are same. So pop out this A and send it to postfix. Then push plus into the stack. Plus is alone. Then B, its precedence is 3. Push it into the stack. The next, asterisk, its precedence is 2. That is 2, but this is 3. So greater one, pop out and send it to postfix. That is 2, this is 1. So this is smaller than that one. So push it. The next is C, this is 3. That is 3, this is 2. That is greater, so push it. Then minus, its precedence is 1. This is greater, pop out. Minus is 1 and this is greater, star, pop out. That is minus 1 and this is equal, pop out. So all the symbols in the stack which are greater or equal, we should pop out them. Yes, we did it. Now there is nothing, now we can push it. So you can see in the procedure that every symbol is going through stack. It's getting pushed definitely in the stack. Nobody is directly going to postfix. Continue. D, precedence is 3 and this precedence is 1. Push it. Slash, precedence is 2. This is 3. This is greater. Pop out D. Slash 2. This is 1. That is greater. So you can push it. E, precedence 3. 3 and this is 2. That is greater. So we can push it. End of expression. Pop out all the symbols and append them to postfix. E goes out first. Then slash goes out, then minus goes out. Same result we got. Even if you are pushing operands also in the stack, it works. But the operands must have highest precedence, topmost precedence you must give. So everything will be going through stack. So that's what this was the variation. Let us write a function for converting infix expression to postfix expression. Function name I have given it as convert. It will take a character type pointer to an array of characters and its name is infix. So that example already I have given here. This is an array of size 10 having that same expression. And it is a string, so it is ending by null character, that is /0. So it's a string. So this is also a string or character pointer. It will convert and returns a character pointer. So that is postfix it will return. For this procedure, I need two more functions. One function is operand. This function is to check whether a symbol is operand or not. If it is operand, we want result to be true, that is 1. So here I am checking the condition. If it is plus, minus, multiply, divide, then it is an operator. It's not an operand. So I am returning 0. Otherwise, it's an operand. So returning 1. The next, we need the precedences also. So if you remember the precedences, plus minus is having 1 and multiplication division is having precedence 2. So I have a function for precedences. For plus minus, return 1. For multiplication and division, return 2. For any other thing, return 0. Any other thing means if the stack is empty, nothing is there, then we should have the precedence 0. So that also I have written. So these two functions I'll be using them. So the code will be very simple and easy to read. Now let us come back to the function. Inside the function, I need few things. First of all, I need a stack. Which type? Character type stack. So in parenthesis matching example, if you watch that video, there I have used a character type stack and also I have initialized it. So same thing we should do here. I will not explain that. I will directly declare a stack. So a structure type stack, that is ST. ST is a stack and that will be holding characters. So it's a character type stack. And also I will initialize it. So I will write a comment here that it is initialized. So assume that it is also initialized. It needs few statements that you have to set the size of a stack and create an array and initialize top pointer to -1. So 3 statements you require. I'm avoiding that. So you can check it in parenthesis matching. The next thing what I need is I need a postfix array to store the result of postfix. So what should be the size of this one? Same as infix size. So I will create an array equal to the size of infix. Here I have taken character type pointer, that is postfix, and also creating a new array from heap and size of that array is equal to string length, and as this is a string we need one more space for null character /0, so that's why +1. Then I need few variables for scanning through this infix expression and scanning through this postfix expression. So I need two integer variables that are I and j. So I have taken I and j, both are initialized to 0. Now the procedure. In the procedure I have to scan through complete infix expression from first symbol till we reach the null character. So we have to go on scanning all of them. So shall I use, so I can use a for loop. So for loop will be taking me through all those symbols. But instead of for loop, I'll prefer using while loop. Reason I will tell you afterwards. I will not use for loop, I'll use while loop. So how long that loop should execute? Till we reach the null character. While infix of I is not equal to null. Until you reach null, continue. Then what I have to do every time? So if you remember the procedure, we were checking every symbol whether it is an operand or operator. So if it is an operand, we were adding it to postfix. So that code I will write down. See, to check whether that symbol of infix expression, let us say first symbol, is it an operand? I'm sending it to this function. So this function returns true if it is an operand. And if it is an operand, then directly I should send it to postfix. So the symbol of infix expression should be stored in postfix, and index I and j both should be incremented. So copying that symbol here. If it is an operand. If it is not an operand, then it is an operator. Then I have to check the precedences. So else, I will write on that part. Else, if it is an operator, then I have to check the precedence of a symbol from infix expression and the precedence of a symbol in the topmost position of the stack. That's what we were doing. So I will write on that one. And if the precedence of infix expression is greater, then push it into the stack. Otherwise, pop out. I will write down that code. Now, here I will read it out. If precedence PRE, this is precedence function, of infix symbol of I, infix of I. So I may be here or here, wherever. I may be on this operator or this anywhere. It's on the operator. So the precedence of that operator is greater than PRE, precedence of stack top. Stack top function, we already know it gives the topmost symbol in the stack, and we know stack is containing only operators. So check their precedences. If the precedence of this symbol that is from the infix is greater, we know we will push it into the stack. Push it into stack st, that infix of I, and also move to next symbol in infix. So if you have pushed this one, go to next symbol, plus plus, I plus plus. If it is not greater, if this is smaller than that one or equal, then pop out a symbol. Pop out a symbol from the stack and add it to postfix. Generate a postfix array. So you remember we were generating postfix. So generate that array. And in infix, remain on the same symbol only. Don't move. I plus plus was done because it was pushed into the stack. But here I plus plus is not done in else part. So that I will not move always. It will not move always. That's why I have not used for loop. For loop means every time it will move to next I. While I am using an I am moving it. If it is an operand, goes to postfix. Move to next symbol. Means if it is A, move to next. Then if the symbol is pushed into the stack, then move to next. Otherwise don't move, because you are popping out a symbol from the stack and add into postfix. Don't move. Be on the same symbol and continue again and check again with the stack top. That's all. This is the procedure. Now the part that is remaining is whatever was remaining inside the stack, we have to copy that in postfix. So that portion, there is no space. So I will remove this function and I will show it here. So here I will write down the code for copying all the contents from the stack. So pop out the values from the stack and go on adding them to postfix until the stack is empty. While not is empty. St, stack. As long as the stack is not empty means When it is empty, stop. If it is not empty, continue. What to do? So inside postfix expression, pop out the element from the stack and add it to postfix. So stack will be containing operators. Those are popped out and added to postfix. So this loop will copy all of them. Then after copying all, I should add a null character at the end of postfix, because postfix is also a string. String means it must be terminated by null character. So add a null character. That's all. We got the result. Return that postfix. That's all. So finally, postfix is return and end of the function. So this function will convert infix to postfix. That's all. This is the program. I will write and run the program and show you.
In this video, we will write a function for converting a infix expression to postfix expression. As the procedure utilizes a stack, so already I have the code for stack. So that is using linked list. So this is the same program, stack using linked list. And this already I have uses for parenthesis matching. Now I will use the same program or same set of function for infix to postfix conversion. But for infix to postfix conversion, I need few functions like checking the precedences. So for that, I will write down function for precedences. Function return type is integer, and let us call the function name as pre for precedence, and it should take a character type value, that is, let us say x. And here, if x is equal to plus operator or minus operator, its precedence is 1. So I should return 1. Else, if it is multiplication or division, then I should return precedence as 2. So if x is equal to multiplication, that is star, or if it is division, x is equals to division, then I should return 2 because the precedence is 2. That's all. We have seen only 4 operators. Based on that, we will convert an expression into postfix expression. Else there is no precedence, so I should return something. I will return 0. Then next, I also need a function to check whether a symbol is a operator or operand. So I will have a integer type return type, and the function name I will write it as is operand, and data type is character. Here, if it is plus, minus, multiply or divide, then it is an operator, otherwise it's an operand. So here I will write on the condition if character x is equals to plus operator or it is minus, I will write all these things. Here I have written addition, subtraction, multiplication, division, then it is not an operand, so I will return false, that is return 0. Otherwise, I will return true. Return true means it's an operand. So that's all. These functions are sufficient for me to write a infix to postfix conversion function. Now here inside the main function, I will take an expression that is infix. So character, pointer type I will take, an infix. I will already initialize this one. So I will take a plus b multiplied by c, a simple expression. Then I take one more pointer for postfix expression. So this postfix expression will be returned by the function. So here I will write down a function for infix to postfix. So return type of a function is character type pointer int to post. I will call it as infix to postfix, so I will say int to post, and the parameter is a pointer of type infix. Then inside the function I need a character type array called postfix, and I have taken a pointer. For this I should allocate the memory. So first of all, I should know the length of a string length. So str length, I can call the function that is string length function to find out the size of infix expression, and depending on that I should allocate the space for this postfix expression. So postfix, I will create a array inside heap of type character. So star character malloc function, and whatever the length is plus 1, because I need to store /0 also, then this should be multiplied by size of character, multiplied by size of character. Now the postfix expression is created inside heap so that I can return it to the main function. Now I need few more things, that is I and j, that are both initialized to 0. Now using a while loop, I will scan through infix expression. So while infix of I is not equal to /0. Then every time I should check whether it's an operand. Is operand, I should pass this infix symbol to that function is operand function, and if it returns true, then I should add it to postfix expression, write j++ assign infix of I++. This is the first thing. Else, if it is not an operand, then I should check the precedences. Check the precedence of infix symbol I. If the precedence of infix symbol is greater than precedence of a symbol inside the stack, then I should call precedence of top caps data. I should send this one. So wherever the top pointer is pointing, that is topmost element is stack top. And if this infix expression symbol is greater, then we will push a symbol in the stack, that is infix of I++. If this symbol is smaller, then we will pop out a value from the stack and add it to postfix. So postfix of j++ will be assigned with popped out value from the stack. That's all. This is what all happens inside a while loop. Then once we come out of the while loop, while the stack is not empty, while top is not equal to null, I should continue and I should pop out all the values from the stack and add them to postfix expression. Postfix of j++, I should assign the popped out value from the stack, pop out from the stack. Then after this, at the postfix end of the postfix, I should also add null character, that is /0, so that it becomes a complete string. That's all. This is ready. Now one thing, when I am finding the precedence of a topmost element, initially stack may be empty, so this may give error. So what I do, initially I will push something in the stack. So push, I will push a symbol, let us say hash. So initially I will push this one. Now inside the main function, we will call this function into post by passing this infix expression, and it should return the postfix expression, and then we will print this printf percentile s expression we will print, that is postfix. That's all. And one more thing, I'll increase the size of this array, that is postfix. I'll add 2 instead of len plus 1, len plus 2. And one thing, inside this function, I should also add return postfix. I should add return postfix, so it should return the postfix expression, and it is taken in this variable, that is pointer, and let us display it. Now let us run the program and check. See, a plus b star plus hash. See, as we have also already included hash inside the stack, so that is also popped out and added here. That is the reason I have taken the size as len plus 2. Yeah, here it's showing me a warning that actually string length returns long type of data, but I am taking as integer, so I may be losing some data. So anyway, this is sufficient for me because the value is very small. To remove this warning, I should make this as long. Anyway, the function is working perfectly. Let us add few more things into the expression. Then here I will write a plus b star c minus d by e. So the postfix form of this one is abc star plus de slash cde slash minus. So let us run abc star plus de slash minus. Yes, correct. We got this result. So that's all. Now in the coming videos, you will find one more method of converting infix to postfix expression. So you have to write on that program by yourself and practice this program. That's all in this video.
In this video, we'll learn how to convert a infix expression into postfix expression if a infix expression is having parentheses and those operators whose associativity is right to left. In the previous video, we have seen there was only addition, subtraction, multiplication, division, only 4 operators I had taken, and their associativity was left to right, but we did not handle any operators whose associativity is right to left, and even we did not consider brackets. So if we consider brackets and the associativity both left to right and right to left, then this procedure works for any number of operators, any type of operators. So, but we are learning with a limited set of operators for understanding the procedure. So I have the operators here: addition, subtraction, multiplication, division, power. Power is right to left associative. These are left to right associative. And I have opening bracket as well as closing bracket. Then there is something written here, that is out stack precedence, in stack precedence. I will explain what is that. I will show you the procedure, and writing a program is a student exercise. So you have to write a program for this one. So I will explain the procedure. So for explaining the procedure, I have taken an expression which is also having parentheses and right to left associative operator. Both are there. So this expression, let us first understand how to convert it into postfix using pen and paper. First, let us get the result. Once we know the result, then from the procedure, we can confirm our result. Let us do it manually. So before doing it, I will add one more parenthesis here. This one, I will enclose it. For converting into postfix, who is having highest precedence? Obviously, brackets are having highest precedence. Right? Brackets are having highest precedence. So in this bracket, we should convert this into postfix. But inside that, one more bracket is there. Convert this one first into postfix. So this is AB plus, put it into the bracket. Then star C, again bracket is there, minus D power E power F. Then which one? This bracket. So this we have finished, right? This bracket. So left side, right side, then star. Left side, right side, then star. This is converted. Minus D power E power F. Then this is completed. Minus power. Higher precedence is power. But associativity, right to left. So convert this one. So this will be AB plus C star minus D power EF power in bracket. Now next, which one? This power. So this is left side, this is right side. So this is AB plus C star minus DEF power, and this power goes at the end. Now this is completed, only minus is remaining. So final answer is AB plus C star DEF power minus. This is the postfix. I will write on the answer there so that when we finish with the procedure, we should get the same answer. So when we convert an expression, we should get this answer. Now let us see the procedure. Now let us see the procedure, how it takes a stack and convert into postfix with the help of this precedence table. Let us see the procedure. So while showing you the procedure, I'll explain why we have out stack precedences and in stack precedences. I'll explain. And the procedure is similar to the one we have seen earlier. Same procedure with a little bit difference. Let us see. A stack is taken. I have to scan through this infix expression by taking one symbol at a time. So what is the first symbol? Opening bracket. What's its precedence? 7. Why not 0? This is outside the stack. It is not inside the stack. So outside the stack means precedence is 7. Okay. Now, is there anything in the stack? Nothing is there. That is of higher precedence. So push that into the bracket. So once it has came in, this has came in, what is the precedence of this one now inside the stack? In stack precedence is 0. Okay, this is 0. Then move to next symbol. What is the next symbol? Again opening bracket. What's the precedence? 7. 7. What is there in the stack? This one. What is the precedence now? 0. So that is 7. This is 7 and this is 0. So 7 is greater. Push it into the stack. Once it came inside the stack, its precedence became 0. A. This is operand. Operand means send it to postfix. Next symbol, plus. What is the precedence? Precedence, it is outside, so it is 1. And what is the precedence of stack top? This is 0. Push it. Now once it came inside, its precedence became 2. Next symbol is B. B is an operand. Send it to postfix. The next symbol is closing bracket. So what is its precedence? 0. See, out stack precedence 0. In stack, it is never pushed into the stack. Why we should push closing bracket? That's why its precedence is not there. Only outside stack. It's outside only. It's not pushed. We don't push it. And its precedence is 0. What to do now? This is 0, but this is 2. This is greater. This is greater. Pop out and add it to postfix. Check next. This is 0. This is 0. Oh, their precedences are equal. So this is the only situation where we get precedences equal when opening and closing bracket. Then what we should do? Pop out. Don't add it to postfix. Don't add there. Don't append. Simply skip it and move to next symbol. Because we got a match, move to next symbol. This is what you have to do when the precedences are equal, and they will be equal only in the situation where you have a closing bracket here and opening bracket here. Otherwise, in this precedences, that is in stack and out stack, precedences will never be equal. Let us continue. Star outside precedence 3, in stack 0, push. Once pushed, what is the precedence? 4. C operand, send it. Closing bracket, precedence 0. This one 4, pop out. Precedence 0. This is also 0. Pop out. Don't add it there. Move to next symbol. Minus, precedence is 1. Anything in the stack? No. Push it. Now precedence is how much? 2. Next symbol D. D. Next symbol power. What is its precedence? 6. This is 2. So that is greater. Push it. Push. What's its precedence becomes? 5. Oh. See, if you observe, till now precedence was increasing when it was coming inside, but now decreasing. Reason? It is right to left associative. So the purpose of giving two precedences is that if it is left to right, let it increase when it is going inside the stack. If it is right to left, let it decrease. So if you want to add more operators in this one, you can add, and depending on the associativity, you can increase or decrease the precedences. See, power is having right to left associative, so this is decreasing. It should be 5, 6, but it is written in reverse, that is 5 there and 6 here. So that's how when it came inside, its precedence became 5. Next symbol E, operand. Next symbol, this is how much? 6. 6. And what is the precedence here? 5. That is greater, it will come inside. After pushing, what is the precedence? 5. Right? So before pushing, we check the condition. Then after that, it is pushed. Now the precedence is 5. Right? Next symbol F, operand. Send it. Next symbol finish. End of this expression. Pop out the symbols from the stack. Power, power, minus. Power, power, minus. AB plus C, AB plus C. Star DEF, star DEF. Power, power, minus, power, power, minus. We got the result. So end of the procedure. Let me once again tell you, here we have included the brackets. Bracket is having highest precedence. If you want more operators, you can add them and give their precedences. As you know, you give the precedences that are your operators. If any operator is left to right associative, then increase the precedence from out stack to in stack. If it is right to left, then decrease the precedence. So in this way, you can add as many operators as you want in this one. So this has given a complete idea by using limited set of operators. So you have to write on the program. As I said, this is student exercise. In this video, we will learn how to evaluate a postfix expression. So here in the example, already I have a infix expression. Let us see what is the value of this one. What is the answer for this one? 3 5s 15 plus 6 by 2 is 3 minus 4. So this is 18 minus 4, 14. So the result of this expression is 14. So directly I have evaluated and I got the result as 14. we will learn how to evaluate if it is in postfix form. We have already learned how to convert infix to postfix. After converting into postfix, we must evaluate it and get the result. That's what we are going to learn now. So I have an expression in infix form, so I will first convert it into postfix, then I'll show you the procedure. Let us convert this into postfix. So this is higher precedence, multiplication and division. So let us convert this one, 3, 5 star, and this is next higher precedence, so 6, 2 divide, 6, 2 and divide. Then this addition and subtraction, 2 are there. So first addition. This is in between this portion and this portion. So both the portions are already there, left hand side, right hand side. So just write plus. Then this as minuses for 4. So 4, then minus. So this is the postfix form. Directly by reading an expression, I have converted into postfix. So if you practice, you can do that. Now let us see how to evaluate. For evaluation, we need a stack. So let me take a stack. So stack is ready. Now let us see the procedure. In the procedure, we will scan through postfix expression by taking one symbol at a time. And while scanning, what we have to do, let us learn. First symbol, 3, it's an operand. If it is an operand, push it into the stack. Next is an operand, push it into the stack. Next is operator. If we get any operator, pop out 2 symbols from the stack and perform that operation. So first pop out 5, then pop out next one 3. So first value that popped out will come on the right hand side, second value come on the left hand side, then we perform this operation, that is multiplication. So 3 5s 15, so we got the result 15, push this result into the stack. The next symbol is 6, it's an operand, push it into the stack. Next symbol is a 2, it's an operand, push it into the stack. Next symbol is divide, operator. So pop out 2 symbols. So first 2, then 6. So both are popped out. And the operation is divide. So the result is 3. Push that 3 into the stack. Next is again operator. So pop out 2 symbols and perform the operation. So first symbol is a 3. Then next symbol is 15. Operation is plus. Result is 18. Push that result into the stack. Now, next symbol is operand, so push it into the stack. And next symbol is operator, so pop out 2 symbols once again. 4 is gone, 4 is popped out, then pop out 18. Then the operation is minus, perform minus. Result is 14, push that result 14 into the stack. End of expression, and the result of the expression is in the stack. So at the end of expression, we got the result of our expression inside the stack. Now few things to observe. See, the values that I have taken in my example are integer values. So this stack is having integer values. So these operations are performed on integers. That is multiplication of 2 integers, 3 and 5, we got 15. So these are integer values. This is one observation. Then the second thing, when you are popping out first symbol or first value, that will become second operand here. And the second value that is popped out from the stack becomes first operand. Otherwise, if you change the order, it will become 5 into 3. Then this will become 2 by 6. So the result is different. So try to maintain the order. And the last thing we can observe here is that the evaluation of an expression is done by just scanning through an expression only once. Now I'll show you the working of this procedure in the form of a table, because this is a repeating procedure, iterative procedure. Iterative procedures can be traced using a table showing you the contents of data structures or the variables, how they are changing. Let me trace this procedure once again and show you. Let us see the procedure once again, and I will show you how the values are changing in the form of a table. The symbol, first symbol is a 3, so push it into the stack. First symbol is a 3, so push that 3 into the stack. Next symbol is a 5, so push that into the stack. So on the top we will have 5, then next we will have 3. I am separating them with comma. Then star. So when you have star, pop out 2 symbols. So first symbol is this one, and the second symbol that is popped out is this one. Multiply and get the result, store the result into the stack. The next symbol is 6, push it into the stack. So 6 comma 15. Next symbol is a 2, push it into the stack. So 2, 6, 15. From the top, if you see, these are the values in the stack. Then divide. So pop out two values. First value popped out is 2, then second value popped out is 6. Then divide them. Answer is 3. So this is 3, 15. 3 is pushed into the stack. The next symbol is plus. Pop out two values from the stack. First value is 3, second value popped out is 15. Perform addition and the result is 18. Push that 18 into the stack. The next symbol is 4. So 4 is pushed into the stack. 4, 18. Next symbol is minus. Pop out two operands and perform the operation. So the first symbol is 4, the next is 18, and if you subtract, the result is 14, so the result is pushed into the stack. So that's it. So this is how the procedure is working, and scanning through an postfix expression, just one. And if you want to know the time taken, it is n. What is n here? The size or length of postfix expression depends on the number of symbols. So for each symbol we have a step. So the number of steps are equal to number of symbols. So the time is sort of n. Even for conversions also the time was n. One interesting thing I will show you here. This is a infix expression. Suppose this is what I have written in my program. The result has to be stored in some variable. So if I write this one, then can you tell me which operation will execute first? Listen carefully. Can you tell me which operator will execute first? So yes, your answer is multiplication. First, multiplication will execute. But let us see which one will execute first. We know very well that compilers will not evaluate infix expression. They will convert infix expression first of all into postfix expression. So in one scan, it is converted into postfix. So let me write postfix form of that one. First, this multiplication gets converted. So this is 3, 4 star. Then this plus is converted. So 6, 5 plus. Then this plus will convert. So plus comes there. If you want to include assignment also, then x, then assignment at the end. So this is the complete postfix form of expression. Then we know how the evaluation is done. Just now we have seen the procedure. We know how evaluation is done. Let us take a stack and do evaluation. So take a stack. So the first thing goes into the stack is x. The next is 6. The next is 5. The next is an operator. So pop out two operands. So 5 is popped out. Then 6 is popped out. And the result is 11. 11 is pushed into the stack. Which one got executed first? This one. This one. So this one got executed first. We were believing that this gets executed first. No, wrong. So that's what I was telling you from the beginning, that precedences and associativity are meant for parenthesization. They don't decide who will execute first. They won't decide which operator should execute first. So you can see that after converting into postfix, when the evaluation is done, first operation that is getting executed is plus, not that multiplication. So the precedent says that multiply 3 and 4. Don't first add all these 6, 5, 3, then multiply 4. Don't do that. Multiply 3 and 4. This is what precedent says. So it shows who should be parenthesized. This is first parenthesis. Then this is second parenthesis. Then this is the final one. Now you see everything is parenthesized. Tell me which parenthesis you will evaluate first. This one we will evaluate first. That's all. That's what happened here also. Plus 1 was executed. But when it is not parenthesized, we believe that, oh, highest precedence, that will execute first. No, not necessary. Not necessary. Unless you know complete parenthesized expression, then you see which bracket has to execute first. That bracket will be executed, or that operation will be executed. So this is one interesting fact, that precedence and associativity are meant for parenthesization, not for execution. Let us write a function for evaluation of postfix expression. And the parameter it is taking is character type pointer, so which can access a character type array, so that is it can access a string. So the pointer name is postfix, so let us assume that it is accessing this array. So as an example, I have taken an array. Then we need a stack inside a function. So I have taken a stack here. And this stack has to be initialized. So in the previous programs also we have seen, We have to do that. That is, set the size, create an array of some size, and initialize stop pointer to -1. Those 3 steps we have to write down. Then next, what I have to do? I have to scan through this entire expression by taking one symbol at a time. So this scanning I can do it using for loop also. Let us scan the expression. Here this for loop will help us scan this postfix expression starting from 0 and every time moving ahead, next, and it will stop when it has reached /0. So when it is not equal to /0, it will continue. When it is equal to /0, it will stop. Then inside this, I have to write down my procedure, but I need some variables, so I will declare those variables. Like here I have used variable I, so I need I, and also I will take x1, x2 and r for result. So I have taken few variables that I'll be using them in this for loop. Now before I write here, before I continue writing, I have to explain one important thing here. See, a postfix expression is in the form of string. String is nothing but set of characters. So each of these symbols are character. So 3 is not a integer value 3. It is having its ASCII code. And the ASCII code for 3 is 51. So actually it is 51, numeric 51. It's not 3, number 3. It's a character 3. Anyway, this is just a simulation function. So here I cannot take 2-digit number. I am taking just single-digit numbers. If there are 2 digits, then how I can know which 2-digit belongs to which number? So it's a confusion. So this is for just one single digit and those are characters. Now let us proceed. Now what I have to do while scanning? So this for loop will take me from 0 to 9, right? It will stop here. So for every symbol, what we are supposed to do? Check if it is an operand or operator. So if you remember in the previous example program, that is Infix to Postfix conversion, we wrote a function called isOperand. That same function I will use it here. Isoperand postfix of I. So if it is an operand, the postfix symbol, is it an operand? If it is an operand, then we have to push it into the stack. So okay, push it into the stack. So postfix symbol is pushed into the stack. Otherwise it's an operator and I have to pop out 2 symbols and perform the operation. So in the else part, first of all, I will pop out 2 symbols. So here I am popping out symbol. First symbol that is popped out is made as second operand and the second symbol that is popped out is taken as first operand. Now depending on the operator, I should perform the operation. If it is multiplication, I should perform multiplication. If it is division, I should perform division. So depending on that, I have to perform the operation. So for that, I can write down switch case here. So here is switch case based on the symbol of postfix expression. In case if it is a plus, then perform addition. So I will write down here. So here the statement is case plus. If it is plus, then perform x1 plus x2 and get the result in R and push that R into the stack and then break, stop, end the case. This is for only addition. Then same way I should write it for subtraction, multiplication and division. I will write down few. So here I have written the cases for addition, subtraction, multiplication and division. Evaluate the expression. Perform the operation on operands and get the result and push into the stack and break that case. So all these are same statements in all the cases. So this switch case will perform the operation and again push the result back into the stack. So if this procedure continues for loop, at the end of for loop, the result will be in the stack. So we should return the result from the stack. So at the last statement, we should pop out a symbol and return it from the stack. So I will write it here. So the last statement after for loop should be return pop from the stack and also return. So this is the end of a function. There was no space, so I wrote it there. So that will be the last statement. Now one last interesting thing that we have to discuss here. What is the type of a postfix expression? String. So those are all characters. What is the type of the stack I should take? Integer type or character type? Integer type. Because when I pop out the values from the stack, I am performing the arithmetic operation. So this is on integer values I am performing. So the stack must be integer. So I'll take a stack. This is an integer stack. Okay. If you see here, If it is an operand, we are pushing a postfix symbol into the stack, pushing a postfix symbol into the stack, right? If it is an operand. Let us take first symbol and try to push it. See, this is a operand and it is 3. So 3 will be pushed into the stack. So that is character 3. But this is stack of type integer. So what will be pushed in? As I said, the ASCII code of 3 is 51. So 51 will be pushed here. Wrong. So we cannot expect good results. So it means for 5, what will be pushed in? This will be 53. 51 and 53 are pushed. Their ASCII codes will be pushed in because those are character. Their number, numeric value is 51 and 53. That is pushed here. It means when this multiplication is performed, it will be performed on 53 and 51. Yes, 53 and 51 will be multiplied. Wrong. It will give us wrong result. Then what I should do? I should convert that character 3 into integer 3. How to convert? Check this. This is character 3. That is 51. Subtract character 0. 0 is 48. Subtract it. We get the result 3. So subtract character 0 from a number, then we get the integer value of that one. So we should get 3 here and 5 here. For that, subtract ASCII code of 0 from each numerical symbol or operand from there. Typecasting will not help. Typecasting of a 3 will give us 51 only. It will not be 3. So when I am pushing the value into the stack, I should not push 51 for 3. I should push number 3, integer 3. So when push here, from the postfix symbol, I will subtract ASCII code of 0. So this is the interesting thing here. So subtract that, those characters will become integers. So that's all. This was the simulation function of evaluation of postfix. See, the infix to postfix conversion is used by the compiler. So when if you are developing a compiler, then you can do it in real. But here we are just looking at how compiler may work, how compiler may evaluate.
In this video, we'll look at a function for evaluation of postfix expression. This is the same program that is programmed for stack using linked list. I have used it for parenthesis matching, and also I have used it for infix to postfix conversion. Now I'll be using it for evaluation of postfix. And in evaluation, I need one function that is operand. So already I have this function which will return true if it is an operand. Now I have to make some changes inside this code because I am going to use a integer type stack. So I should change this node type as integer, and the push function should take a integer. Then pop function should also return a type integer, and here is also an integer. So I have to use a integer type stack. So I have made some changes. That's it. Now let us go to the main function and add eval function also. So inside the main function, first of all, I will declare a postfix expression. Let us take a postfix expression as 234 star plus. This will be 14, that is 3 4s 12 plus 2 14, and 82 slash minus. So this will be 4 minus. So 14 minus 4, it should be 10. So I should get the result as a 10. So now for this postfix expression here, I will write on a function for evaluation of postfix. Let us call the function name as eval. Then it takes a pointer to a postfix expression, and inside this I need few variables like I for tracking through this postfix expression, and also I need some variables like x1 and x2 and for storing the result. Now using a for loop, we can scan through this expression. So I assign 0 as long as postfix of I is not equal to /0. We should continue, and every time I plus plus. Now every time we should check whether it's an operand. So I should say is operand by passing postfix symbol I. If it's an operand, then I should push it into the stack. Push that postfix symbol I. Else, if it is not an operand, then it's an operator. Then for operator, I should pop out two operands from the stack. So first one is x2, then second one is x1. Then depending on the operator, I should perform the operation. So switch case I can use upon postfix of I symbol. Now inside the case, first case, if the symbol is plus operator, then a result should be x1 plus x2. Then give break. Then same way I should write for all. So I will copy this one and I will paste it for all other operations. For all four operations I have written, this is plus, then this is minus, and this is multiplication and division. Now here operations also I should change. This is multiply and next one is divide. Then once I get the result, I should push that result into the stack. So push R, that is result is pushed into the stack. Then at the end of the for loop, I should return the topmost element from the stack. So say return topmost element of the stack, top data. That's all. And one more thing, as I have explained you that from this postfix expression, we will be getting characters. We should convert into a integer. So I should subtract the ASCII code of 0, or I can subtract 48 also. So this will subtract ASCII code of 0. So 0 is subtracted and it is pushed. That's all. So this is the function which we have already seen it. Now here I will directly print the result written by that function percentile. Result is percentile D and then slash n also. So I should call the function that is eval by sending postfix expression. That's all. Let us run this. That's all. We got a result that is 10. As I already told you, the result of this expression is 10 and we got the result 10. You can try with the different values with different expression and you can check your answers. Implement this program by yourself. That's all in this video.